Well, welcome. I hope you're here to hear about Kotlin, because that's what I'm going to be talking about. My name is Justin Lee. I work for Red Hat. I don't actually use Kotlin at Red Hat at the moment for reasons, but I'm a big fan. I've been using Kotlin since 2012 at the earliest known as a blog. Anyways, I've been using it for a long, long time, and I'm a big fan. So I'm really excited that it's getting super popular these days, and that you're all here with me. So just so I have kind of a feel for where everyone is, everyone's at least heard of Kotlin or you wouldn't be here, right? That'd be weird. Maybe not entirely, but so who has used it? A handful. Oh, good. Then we have a whole room full of people who are ready to really start from scratch. Excellent. So the agenda for today, we have 3 hours, which is a really, really long time for everybody, for me to talk and for you to kind of take whatever in. So I presented all of this material before, usually in session format. So you go to like a conference and I'll speak for like 45 minutes and take questions and everything. But I've never done it in like a 3-hour stretch before. So it's going to be a journey for all of us, right? So I have a massive script, and I'll either burn through it in the first like 45 minutes because I'll talk too fast, or we'll find ourselves at 3 hours and I'm only like 2/3 of the way through the script. But what the real variable it is for me is I like it to be interactive. I like when people, like if you just go to a session and someone just talks at you for like an hour and you go home, like you could have read a blog post for that, right? You didn't pay to read a blog post. You paid to come talk to people and get your questions asked and hopefully answered, right? So for me, what I like to do as I'm going through is if you have questions as we're going through something, just throw your hand up and ask a question. We can clarify, we can dive deeper, we can make a note to circle back. I actually prefer that particular method because my goal for you guys, for you people, is when you leave here to have a better understanding of Kotlin and whether or not you want to use it in your projects or not, whether it's backend or Android or whatever you might happen to be doing. So to help me make sure that you get that value out of it, I want you to feel free to ask questions, right? Because that's what we're here for, is you're here to learn and I'm here to try to help you learn. So ask your questions as we go along. I have a whole script and maybe I'll say we'll get to that in a minute. If not, I'll try to answer your questions. But don't be bashful because I really honestly don't mind. Does that make sense for everybody? Okay, so I've introduced myself. I'm going to go ahead and show this slide because sometimes I forget at the end, especially as we're trying to like cram in the last few minutes. There's a couple of resources, around the interwebs. The Kotlin Lang website is really great, actually. If you have not been there, there's a whole very comprehensive tutorial. Some of the examples that I'm going to be using actually come from that website, which I sort of feel like is a cop-out for me because I didn't like generate some of these examples. But I kind of like doing that because it gives you something we can talk about here, and then when you go read your own resources, you're like, oh, I remember that example, and then they can expand on something that maybe I glossed over in the session, and you're not having to switch context around things. But anyways, so the Kotlin Lang website is great. The Slack channel I haven't checked in a while, but last time I checked had something like 18,000 people connected to it. So many people, and a lot of the JetBrains developers are on there, so you'll find someone who can answer your question, hopefully, if you're there. If you're any IRC people, anyone know what IRC is anymore? I have a lot of younger friends who are like, what's IRC? And I feel old. Anyways, if you're the IRC type, I'm on this channel. I run the channel, actually. It's great if you like IRC. There's try.kotlin.lang is an online REPL if you just want to like play with stuff but you don't want to install anything. You can actually write and compile and run code in your web browser. And then, of course, Meetup. I'm one of the co-runners of the New York City Kotlin Meetup, which I know doesn't help most of you because most of you probably don't live in New York City. But there are literally meetups everywhere. There's a couple in London, I think. Look for one, find one, and if you don't see one, maybe you'll love it enough to start your own, and you can be the hero. So, before we go on, are there any questions before we start? And the one thing I always forget to do is raise the font size. I didn't know how big the room was going to be, so I didn't do it beforehand, and then my computer froze. So, move this out of the way. Oh, it didn't do it. It's in the editor, of course. I changed the wrong font size. That's fine. 20, apply. All right, back of the room. That's not going to be big enough, is it? Let's go for 30. I'm going to full screen this. Is that readable in the back? Do you want it bigger? Is that an okay or bigger? Okay. All right, I'm getting thumbs up from the back of the room, so I'm going to assume that that is okay. If it's not, just let me know, and I'll bring it up. So this is the script that I mentioned that we have, and there's a lot of content here. Some of it starts with the very basic, and some of it moves on to the really kind of more obscure, esoteric sorts of things. We're going to try and get through most of this. Some of it we may not, some of it we may. But there's a lot of material to get started here. So let's get going. Let me just describe Kotlin briefly, just in case you're. It's statically typed. It's on the JVM. It's not a closure. It's not a groovy. If you're familiar with Java, this hopefully the basic stuff will be pretty easy to pick up. It's not terribly exotic. It was designed to be a journeyman's language. How many of you use Scala? Did you find it hard to get into it sometimes because some of the concepts are really complicated? I'm not trying to draw a judgment on it. It's a very complicated, powerful language. I tried for years before I found Kotlin to get into it, and it was just the context switch between Java and Scala was so large. As trying to learn it on my own on the side, it was just too much work, and I just never could quite do it. And then I found Kotlin, and it was designed to be a journeyman. The journeyman term makes sense to everybody, right? It just occurred to me that might not be. Anyway, it was designed for your everyday average programmer. You know, it's not an academic language. It's not research. It's not trying to break new ground. Most of the features that you'll see in Kotlin, you've seen in other languages. They didn't try to move the state of the art forward necessarily. They tried to take all the language features over the last 40 years or ish, whether it's functional or object-oriented or whatever, and combine them into some sort of cohesive whole, with the goal being productivity without having to be terribly clever to get there, right? So you're not going to see anything, well, it might be new to you, but in terms of computer language science stuff, there's nothing terribly new in any of this. But it is combined in a rather nice way that's accessible and usable. Right, so nothing exotic, and it just combines known practice. So at a very high level, that's kind of what it is. It's multi-paradigm, so you can do functional, you can do object-oriented, you can combine the two, which is kind of where the world is moving for the most part. And it's also very popular on Android, which most of you have probably heard. We're not going to be covering Android because I don't do Android development. We're going to just focus on the language itself. I thought about pulling in some Android stuff, but then it pulls in all the platform things with Android, and it's just, I don't know it well enough to be able to say people should pay to hear me speak about it. So, if I'm being honest. So, let's start with a class. Just like Java, it's single inheritance. So you can't do multiple concrete inheritance just like you would in Java. So if we look at a basic class, it's hard to choose what model to work with. In this case, because you want something complex enough to show some variations, but you don't want to be domain specific. I've chosen to model a very simple library. It may be a little bit too pedestrian, but it'll at least show off the language features I want, and we'll move on to something more interesting. So in this case, let's start with a book. And I'm just going to keep my script open on the side here so I can follow along. Close you. Get rid of you. Okay, so this is what a class looks like. And if you've done Java, I'm assuming a base level of Java, right? Has everyone done Java? Okay. Because I make that assumption and it usually works, but every once in a while people are I don't know Java either. So this is a class, and it looks pretty familiar because everyone's done Java before, right? So, but there's a few differences here. You'll notice there's no public on the front of this, but this class is actually public. So when they were designing, in the early stages of Kotlin, the default was something else. But they did, JetBrains went through and did a scan of GitHub projects, of Java projects, to find out like what's the most common visibility scope applied. And of course that's public, especially at the class level. Like 98% of all classes are public because that's just what they're meant for, right? So they chose to make public the default modifier, or the default visibility, because it reduces the boilerplate and the code that you have to write just to get your basic level thing. So that's one thing to note, because in Java we're trained, make everything, especially like private by default when it comes to fields and properties and stuff. They're all public, and that's fine, and we'll see why in a bit. But so public class, it does not extend anything, and then make sure I'm not getting ahead of myself. They are, more importantly, they are closed by default. Okay, so in Java, if you wanted to make sure that no one could extend your class, you'd have to put final on it, right? And that's how you explicitly said no one's going to extend this class. In Kotlin, they're closed by default, which means you have to explicitly open them for extension. And then if you wanted to do that, in that case, you would apply the open modifier, and now I can extend this class. But if I were to try to extend class whatever, and I wanted to extend book, there'd be a few problems with this code, but we'll get to that. More importantly, you'll see, can you see the bottom bullet? I've never figured out how to make these little tooltips larger on the screen, so I'll just read it to you. It says, this type is final, so it cannot be inherited from, right? If we do open and come back to it, now we just have one squiggle. So what the second red squiggle means is that there's a super constructor that we're not calling, right? Because in the JVM at least, you have to call super somewhere. So the way that looks in Kotlin when you're extending another class is simply, oops, we don't want that. We want this. Because this book section here is actually an expression of sorts. It's both declaration and expression. But this is how you call the super constructor when you extend a type. Now we don't have any parameters there on the super type, so there's no parameters in here, and we'll take a look at that. When we move on to properties, we'll move things around and we'll see what that looks like. So you'll notice here one big switch is the type comes after. Now this looks pretty familiar because in Java you do the same thing. You say public whatever extends book. But in Kotlin, the type always comes later. And that seems a little weird, almost an arbitrary choice. But the difference is Kotlin does type inference, so you don't have to explicitly declare a type, right? In this case, let me see. I'm going to turn on. Sometimes I show it, sometimes I don't. The idea will show you your type hints, and it's not on for whatever reason in this type. But because you're assigning title to a string, it knows that the type of title is string. So there's no need to declare it. So you can just leave it off. And why I mention that is if we did the entire thing that way, we had to do this. I guess the string is simple enough it didn't show the type in. Can everyone see that type in where it still says list author? That's an IDE thing. It's not actually in your source code. You can turn it on, you can turn it off, but especially if you use a lot of type inference, that's super helpful. Because especially as you start looking at, if you're doing like strings and all your kind of functional mapping and flat mapping and everything, the types can change on the intermediate steps. And you might wonder like, what in the world is my type at the moment? Because your map expression was wrong and you were returning a type that you didn't expect. This can be helpful. It can also get a little noisy in your IDE, so you can turn it off if you like, if you're comfortable with what you've got. Anyways, the point being is this. Without all the types in the system now, all your variable names still line up and it's still readable. Whereas if you had all of this stuff on the other side, like you would in Java, which is, I know Java has var now, but I'm curious about it. You have to kind of zip back and forth to read the source code, right? And that would just get, it increases the burden necessary to read your source code. So at least for that reason, and there's probably others, the type comes after. So anyways, slight digression. You can mark a class abstract, of course, as well, just like you would in Java, and it looks exactly the same way. And override. We'll get to it. Okay, so let's talk constructors. Now, well, let's take a brief diversion. I tried to organize this in a way that flows, and it doesn't always work because things come up. But let's take a brief conversation about properties. So you'll notice here we have 4 types on this particular class, and these are properties. They are public, and they are mutable. So if you've done Java 10 with the var keyword or Scala, var will make sense to you, but it basically means it's variable. It's a mutable value type, or a mutable type, essentially. So I can reassign title to whatever it is that I want to do at this point. I could also mark it as val, and now val is essentially a final type. I can never change title past the constructor, right? So that's what that means. Now, you can declare your properties this way, and this is perfectly valid, but sometimes the question is, but I want to set these as part of the constructor. Like, in a proper OO world, all your properties would be exposed via constructor, and you couldn't construct a type without assigning all your properties, right? That's the proper way to do it. With this way, it's not actually possible because I can construct a book now and not pass anything. So everything would be these default values, which maybe is fine. The other way to do it is you could move these properties here. And now what we're doing is we're declaring a constructor for the book that takes one property at the moment called title. And now, in order to construct a book, we have to provide a title. There's no way to construct a book without passing a type. There's a couple things to note here. There's a red squiggle. Can everyone see the red squiggles? I keep mentioning them, and sometimes the color is not so great. I can change the theme so it's all white if it's easier to read. Would that be easier? No? Okay. So one thing to note here is when you're declaring these constructor properties is the type inference does not necessarily apply. So you have to declare a type there, and then you can do that. And now, if you look down here, and this is probably harder to see because it's just under the parentheses, there's a red squiggle on book because I'm trying to create a book without passing a parameter. So a few things to notice here is you'll notice there's no there's no new keyword, right? Kotlin doesn't use the new keyword. It's a little bit useless line noise. We know that we're calling a constructor, so prefixing that with new is just it's a little redundant, at least according to the language designers. So you would just call book and pass in with parentheses, and that's how you call a constructor. In this case, we have to pass in a title. We're going to create a book called Hi There. And so now we've created a book. So if you were to have multiples, you could just a comma delimited list. And we need the type string. Now, let's take a look at our whatever class down here. And we have book. We're extending it. And you can see lots of squiggles here as well, because we're not actually passing in values to the superconstructor, right? So you could hard code stuff in there. We could hard code Hi There. And what does it say? Oh, type is final. And so now that works if you want to explicitly pass in a constant. But more likely, you're going to have something here. So let's say we have name. We're going to give it a string. So now that compiles, and if you wanted to pass in that, it would look like this. So now we're taking in a name to our whatever class, and we're passing it as a parameter to the superconstructor, parent constructor. And there's a couple of things to note here as well. You'll notice that there's no val or no var in the constructor. Okay. So the difference here is this: if you use the var keyword or val, this becomes a property on the class. So it's not only a constructor parameter, but it's also a property on the class. So you can reference it like a field later on. If you were to take it off, that means that title is only a constructor parameter. You can only use it in the constructor, which we'll look at an actual constructor body here in a second. But it doesn't live on past the invocation of that constructor. And sometimes that's what you want, and sometimes it's not. But why I mention that here is you'll notice that there is no var on this one, because we're not trying to declare a name property on whatever. We just want to take in a value so we can pass it into the parent constructor and use that as a property later on. You could, if you wanted to do that, and you'd have, in this case, you'd have two fields on your instance that have the same value, because they're essentially the same thing. So that's the difference between val and var as a constructor parameter. So, constructors. Normally, if you're just doing most constructors are pretty basic, right? You're just taking in values and assigning them to fields on your class. And most constructors are that way, right? In an ideal world, they'd all be that way. But sometimes they're not. Sometimes it's a calculated value based on whatever. So, has everyone seen the init keyword in Java? It's usually static init, right? Because you're doing a static init block. So Kotlin does init for constructor bodies. And in this case, if I wanted to print line something, now my constructor will not only create a book instance, but then it'll print out the title. It's not terribly useful in this case, but you can do very complex things inside your constructor body just like you would anything else. And then you can use, if you just have constructor parameters, you can reference them inside the body, but you can't, for example, set the ISBN. This actually might work. Now, I was going to be all clever and then got caught up by the compiler. You'll notice that I can actually reference title in the field declaration. Can anyone guess why? No? No one brave enough? The field, all these field initializers actually happen inside the instance initializer. So all these assignments are actually technically part of the constructor execution. So all the constructor parameters are visible for your field declarations. But if I were to declare a function, which we'll talk about in depth later, and I tried to print line title, there, it's all red now because title doesn't exist anymore. But it does at field initialization time, and it does in the constructor. And then if I put this back, you can see now I can reference title again. So it's a little bit of a subtle difference. It's not terribly complicated, but if you're trying to figure out, where'd my variable go, it's because you didn't declare var or val. So those are there. Missing, yep, init. So secondary constructors. There's a constructor keyword to declare this, and this syntax is a little bit strange. But remember, when you declare a constructor, you either have to call super or you have to call this, right? You have to, one way or another constructor has to get called, right? And in Java, it's usually an explicit call somewhere. So in Kotlin, it's always explicit, and then we'll do name. There is, and it's red, of course, because there is no name, but we can add parameters here, and we can make it a string. Now, what you cannot do here is you can't do field or property declarations on a secondary constructor. If you want to do constructor-defined property definitions, they have to happen on the primary constructor up here. Because not everyone will call the secondary constructor. That's why it's secondary. So declaring new properties there is problematic. So you're not allowed to use var on that. And in this case, we have a cycle because both parameters are fine. We'll say, make it something different. There was a cycle because both constructors took a string parameter. So this is what you'd do as a secondary constructor. Now, I've been doing, like I said, I've been doing Kotlin for a while. This is not terribly common, at least in my experience, but obviously is useful in certain circumstances. And this is what the syntax looks like. I don't remember if you can do super. Right, primary call constructor. Primary constructor call expected is what that error is. So the super keyword is there, but it doesn't work in this particular context because we have to call the primary constructor first. No. Right. There are things to talk about the subtitle parameter there, but we'll get there in a minute. I want to make sure we cover everything on properties first. Okay. Now, I mentioned that all properties are public by default, right? So the way that it works in Kotlin is whenever you call, we've created our book, and now we want to, let's say we want to print line book.title. Let me scroll this down for those in the back of the room. I'm normally standing, and this is normally higher, so if it scrolls off the bottom and it's lost amongst someone's heads, just wave at me. I'll try to make sure everything's up on top, but sometimes I forget. So the way this looks is, in Java, that would be a field reference, right? We're directly accessing the field, and that is a no-no in Java, right? Encapsulate, mark it private, use a getter, right? That's what we've been taught from day one in Java. The way that works in Kotlin is you just access, because it's a property and not a field, right? And so what that means in practice is that when you compile the bytecode down to, when you compile the source down to bytecode, what's actually going to happen is there will be a field on the class, and what will be generated is a getter and a setter in the bytecode. But Kotlin hides that from you because you can tell from the source what it is that you're trying to do, whether you're trying to access the field to read it or it accesses it to write it. The syntax is enough to know what needs to happen. So behind the scenes, what will happen is the compiler then will call your get or your set appropriately, but it saves you the hassle of having to worry about that in your source code, which is handy. But that, raises the question like, what if I don't want people to set that value? I want people to be able to read it, but not necessarily set it, right? Excuse me. Well, the obvious answer is you can make it immutable, right? And that's a perfectly fine answer. And then you just mark val, the title as val. Fine. I set it once. Everyone can read it. No one can set it. So if I tried to do book.title is equal to something else, you can see that it's in red squiggles because book.title is val and cannot be reassigned, right? But say it's a calculated value. Say it's, in the case of a book, for example, how many times this book has been checked out, right? That's obviously a mutable property, but you don't necessarily want anyone to be able to set it because you only want to be able to set it during certain points of time, right? So this syntax gets a little weird, and we're going to get rid of that constructor. So we have our title, and right. So you can actually define explicit gets and sets for your thing, for your properties. So you'd reference it by get. In this case, we want it to be mutable. We had to assign a value because it's a string, and we'll get to that in a moment. Because string can't be null, and we'll talk about it. So we want to be able to get this value out, but not set it externally, right? So we can have a set, and then we just do this. So everyone see that? So what this now says is that when the compiler generates the set method, it becomes private. So internally into book, I can mutate title anywhere I want. But externally, you can see here that this assignment is still underlined with red squiggles because it has a private setter, and it says, the tooltip says, cannot assign to title, the setter is private in book, right? So that's how you'd hide the setter if that's what you want to do. You can also, if you were so inclined, you can also define your own setter. So say you want it to be mutable, but you want to be able to add some sort of validation. You don't want people to set an empty string for the title, right? Because a book with no title, who's going to read that, right? So you could say if value is not equal to the empty string, then you can say field is equal to value. And I'm going to type, oh, right. Why is it doing? Oh, because it has this body, perhaps. Oh. Obviously, I don't do this particular thing very much either. But this is the syntax for setting the setter, and you can reference the actual field value with this field keyword. I'm not sure. Required unit. Oh, it doesn't matter. I don't want to dig in too deeply because this is also not very common, but you can do this. It's more common for me to use get. You can do get that way as well, and you can reference the field as well that way. So you can define the explicit gets and sets if you want. It's not terribly common, as I said, unless you want to do some sort of validation, and normally I don't. So let's talk about nullability. Does everyone know that Kotlin supports nullable types? Does everyone know what nullable types are? Okay. This is actually, if this was the one thing that Java took from Kotlin, I'd be really, really happy. There's a lot that Java could learn from Kotlin. But nullability is this notion. So let's go back down to our little function here. We're assigning book.title to something else, right? But let's say we wanted to clear it. We set it to null, right? That's what we do in Java. But you can see null is now squiggled out. It says null cannot be a value of a non-null type string. So Kotlin builds in the notion of nullability into the type system. Now in Java, if you call a method, you get some sort of type back. It could be an integer. It could be a deferred whatever. It's some sort of a type. But you don't really know if it's null or not, right? And so you're having to do if foo is not equal to null, then do something. And if you do chained method calls, every step can be a null, and every step, in theory, you should be checking. But not everyone does, right? It's like, I know it's not going to be null, because it's annoying, right? To break out if blah equal not null, then call this, and then if that's not null, call that. It's ugly, right? So no one does it, even though we all should. And then we get null pointers, and we're angry because I thought that would work. So Kotlin fixes this. For the most part, you can break it, of course, because it's just code. You can do anything. So, string is a non-nullable type, as we've seen. To make it nullable, you do this. So that's a string, and it's a question mark, and the question mark indicates that this particular reference may be null. We're not sure, right? So the compiler will actually yell at you if you don't check for nullability at that point, which is nice because 99% of null pointers could be caught if the compiler knew. Has everyone used the at not null and at nullable, something like that? You can use that, but then you have to configure your compiler and your build to check that, and it enforces it. So if you use it, it's nice, but you have to go the extra mile to make it work. In this case, Kotlin will do it for us. And where this gets interesting is, let's do title, and we want to print out, not single. We want to print out the length of the book title, because why not? Now, it's probably hard to see. Let's get rid of that. It's probably hard to see because it's just the single dot, but there's a red squiggle underneath that dot because we're trying to dereference title, and title might be null, right? This is going to get us a null pointer at some point. It's going to happen. And so the compiler will actually fail to compile your code because this is a known bug, right? So there's a few ways to get around this. The simplest way would be to do this. Question dot. Now what this says is if title is not null, then continue on the expression. But once you hit a null, once that title is found to be null, it stops. And if we were to run this, we would actually get null printed out because there's nothing there. We might get 0 because the type would be, that's an interesting question. Let's just do this. The magic of type inference. Okay. Can everyone see that int question mark? So the compiler knows that it's either going to be an int, 13 characters long, or it's going to be something else. In this case, it'll be null. It won't default to 0. So we, in this case now, we've dealt with that. We're not going to get a null pointer, but we might get a null printed out, which is also not helpful, right? Just a quick side note about these other types before we get too far in. You'll notice that this is int, capital I int. It's not integer. It's not lowercase int, right? So it differs a little bit from Java there. The other types are capital D double, capital F float, just like you would. I'm not sure why they went with int here and not integer. It's maybe because integer is too long. But so there are no primitive types in Kotlin. Everything is an object, right? And a slight digression for people who are into bytecode trickery is you would argue like Java has primitives because objects are expensive, right? They're a lot to work with, their memory, their execution time. And that's why in the early days the JVM had primitives, because a pure object language would have been too slow for the JVM at the time. So Kotlin actually cheats. Okay? If your property is a type int, capital I int in Kotlin, it's a non-nullable type. So it knows it'll never be null, right? What else can't be null in Java bytecode is small I int, right? So if your property is int, it'll compile down to Java's int, the primitive type. So in the bytecode, it'll all be primitives. So you get like your native normal execution speed. If it's an int question mark, it might be nullable, but of course the Java int can't be null, right? So your code would break. So in that case, the compiler actually emits an integer type, which can be null, right? So in the bytecode, it handles all that for you, but in the source code, you're just dealing with int. You're dealing with double, right? And then all the weird things about whether it's a primitive or an object or whatever, the compiler hides for you. So like a little hidden performance tip, use non-nullable types if you can, because then you get the primitives. And of course, your code will be nicer because you know it's going to be null or not. But then you would treat it, you could assign, if you had an int, you could say val number is equal to 0. So you could treat it like it would be anything else. You just use numbers, and the compiler is fine. It knows what's going on, even though technically it's not. So you could do this as well, and you still treat it as numbers. Whereas in Java, you have to say like new integer blah or integer.value of whatever to wrap it properly. You could autoboxing. Oh, that's another point. I know I'm digressing a fair bit, but there's so much. There's no autoboxing in Kotlin. The type promotion has to be explicit, which is nice because it hides a certain class of bugs, but it is slightly more verbose than Java is, which is an oddity because usually Kotlin is less. But, all right. Back to nullability, because that's the more interesting bits. So the problem here is we want to print a message. We were originally printing the title. Now we're printing the length of it, right? But we want to print something out other than null, right? Because null doesn't tell us anything other than something went wrong, obviously. So one way to do this is you could do this. You could say if message is equal to null. That looks familiar, right? Then you could print line something else. You could print a message. Now we're either going to get the ellipses or we're going to get a number, right? So your traditional Java null handling works just fine. It's a little bit more verbose than perhaps you need. But everyone who's done Java or really any C-based language knows what that code will do, right? It's not complicated. The microphone just fell out of my pocket. So, but there's a better way to do this, right? And there's a couple ways we could do it. There is the Elvis operator here. Now we can do this. Now you can see the inferred type came back to any, which is another thing to note. Object is the parent type of everything in Java. In Kotlin, it's any, right? And this is, it's sort of important and sort of not, but you can also have an any question mark. So it could be any type non-nullable or any type nullable as well. And it would look something like this. It would just look like everything else. So there's a parent type any for everything, and we'll get to it later. But there's also a base type of everything called nothing, which is, it sounds weird, but we'll see why in a while. There's a type called nothing, and nothing extends everything, essentially. It's a compiler trick. I don't think you can actually declare a type of nothing. But we'll see that in a bit. It's usually around exception handling. But anyways, I digress. So now we're either going to have, our message is either going to be the length of our title, but if it's null, we're going to actually print out a string and says book has no title. And so now we're guaranteed to have a meaningful message in the case that the title is null, right? So that's one way to do it. And there are other ways to handle it, but we'll get to those later because I want to deal with the rest of this. There's one more kind of interesting way to do it, but when we get to bits down the line, we'll cover it in more in depth. So we've had custom gets and sets, nullability. Now, the problem here, who saw this and cringed when I declare it to be an empty string? Anybody? Is it just me? There's a few hands. It's okay. Express your opinion. What we really want to do is we want to say this, right? A book is going to have a title, and we're not going to give it any choice, right? Now, you might ask, why would you want this? If you use any sort of object mapping, whether it's Jackson or Hibernate or whatever, you know that you're getting an object model in from some sort of external source. We'll work with JSON for now. And you know that inside that JSON there's going to be a value for this title. And so you want to declare a model inside your Kotlin code to reflect that JSON model coming in. But you don't want to make it nullable because then you'd have to do all the question mark operators everywhere. And you don't want to initialize it to a string because perhaps what you really want, you don't want to initialize it to a string because it's kind of gross and dirty. So ideally you just do this, but as you can see, red squiggles, right? Compiler complains. There is a workaround around the nullability requirement called Lateinit. Now what this says to the compiler is that we're going to initialize this variable later. It's going to be Lateinitted. And what this lets you do is it leaves you as a non-nullable type, but you don't have to declare some sort of initial value to it. This lets, say, Jackson come in, create an empty instance of book, and then as it reads in the JSON, it'll read in a value and it'll set that property in later, right? So now when we go to reference it down the way, let's get rid of this. This question mark is in a yellowish, brownish box. Because title is no longer nullable, we no longer need the question mark operator, and we can just dereference it normally, right? So this is useful when you're doing object mapping sorts of things. I actually use this quite a bit because I work with object mappers in a number of capacities, and it's super useful for keeping your model clean, but still allowing some sort of late initialization. So. Yeah, I have the note here, it feels like a mild abuse of the type system, but it's better than what came before. Early in the world, in the Kotlin world, if you knew that title was not going to be null, you could actually do this. You still can. There's an operator double bang, and that tells the compiler, I know the type system says this might be null, but I know in my heart of hearts it's not going to be null, so ignore the null. But this means double banging everywhere. And this is how Kotlin originally worked, and it was terrible. There were double bangs just everywhere. It made the code look gross. So one more digression, and we'll move on to functions. So the fix for this, where this really comes up, is if you're all in Kotlin, it's great, because the type system, it's either nullable or not nullable, and it's fine. But one of the nice things about Kotlin is you can use whatever Java library you want, right? That's one of the points of Kotlin, is it seamless interoperability with the JVM and your existing libraries. If you went to Scala, you had to learn a whole new collections API. There's a whole new everything API, right? You had to learn it all, a whole new ecosystem. Kotlin didn't want to do that. There are, it has some additions to the collections API, but if all you ever wanted to do was just use your normal Jackson or Hibernate or whatever your favorite Java libraries are, you just use them from Kotlin and it's fine. Where it breaks down though is there usually is no indication in your Java libraries if something can be null, right? You just kind of have to trust that when you call your Java library, what comes back is not null, or you can be super paranoid and treat everything as if it's null. So Kotlin introduces what's called a platform type. And you'll see it if you have the type hints on. You'll see a type that comes back and say this list of author thing was a function call off into some Java library. What you get back is a list author and then a single bang after it. And that indicates that it's a platform type. And what that is, it's the Kotlin compiler and syntax parser saying, I trust you enough to know that you're saying this is not null. But it is a type, it is a value being returned from the platform, in this case the JVM, there are others. But it is coming back from the platform where there are no such guarantees, so I'm leaving it in your hands whether or not you want to say it's nullable or not. It's a type hint only. You can't actually declare your own platform types, because that wouldn't make sense. If you know enough to declare a platform type, declare it null or not. But especially in the IDE, you'll get, in IntelliJ at least, you'll get these hints to say, this might be null, but I'm going to trust you. You know what you're doing better than I do. But it is an indicator that you might want to consider potential nulls coming back. Now, the nice part about it is the Kotlin compiler actually is null annotation aware. So if you use, there's like 3 or 4 implementations of the whole @not_null annotation. I think JetBrains has one. There's a handful. If you use those, the Kotlin compiler actually respects those. So it can use that to then infer like, oh, you annotated this as not null, so I know that it's not going to be null, and the type coming back will be a non-nullable type. So the Kotlin compiler will honor that, even though, say, Java-C has no idea really what it means. But that's a platform type to be aware of. And I'll admit I've written double bang code from time to time because I'm just sick of it. But it is not the preferred way to do it. There are better ways to handle null that we'll see. But, okay, so before we move on to functions, does that make sense for everyone so far? Any questions? No? Good. All right. Okay, so we've already seen a function, but let's dive into it. So in this case, we're having a function called test, and all functions are prefixed with the word fun. Why not func or def? Groovy uses def. I think Ruby uses def. I don't know why they went with fun. All sorts of jokes come up. It's like, it's fun! But they're all terrible. Anyways, so a function is declared as fun. Now in this case, you'll notice, well, your basic function or basic method in Java is, public, private, void is the return type, and then the name, and then parameter list, right? You'll notice that this has none of that. So the default value, the default return type for any function in Kotlin is a type called unit. Now, unit is roughly equivalent to void from the Java world. I think there are, if you really dive into it, there are slight differences between unit and void. But unless you're doing some very kind of low-level, like reflection-y type things, it's mostly a difference without distinction, right? You can treat them as interchangeable, and almost all the time you'll be fine. I've not been tripped up by any such assumption. But you could explicitly say, turn off caps lock. You can explicitly say, I'm going to return unit. So you can, if you want, you can be explicit about it. You'll notice that it's all grayed out because IntelliJ knows, like, it's the default return type. It's redundant, and it will prod you to remove the explicit type specification. You could, of course, you could turn it off if you want. Like, I like my types, and you can list it if you want. But you don't have to, right? Now, just like with properties, the type comes after the property declaration, right? So you have name and then type. So if your function was to return something, let's say in this case we want to return an int, it would look like that. Colon, int, and then returns whatever that type is. And then, of course, down here, you'd have to return something. You have to return some value. So that's how that looks. Pretty straightforward. Now, a few of the things that make functions more interesting. My script is weird. So Kotlin has something else that I wish Java would take, but it doesn't. It has named parameters. Okay. So let's say fun, it's a test. We're going to have a parameter called foo and a parameter called bar, because that is how we do. Now, these are just normal parameters. It's fine. Nothing to see here, right? So let's declare another function, and we're going to call that test, right? So we have to pass in values. We can say we'll pass in 42, and we'll pass in what? So that looks all pretty straightforward. Nothing exotic there. We've all written Java. Big deal, right? You can also do this. You can say foo is equal to 42, and bar is equal to what? Now, for this alone, it's a little bit verbose. Like this is, we're trying to get rid of boilerplate. Now we just went and added some, right? So in this particular case, I wouldn't use it because, it adds line noise. Where this gets a little bit more useful is if we did something like this. And this is probably a terrible example too, but we'll add it. So without these type parameters, you just have 42 and 13. What does that mean? What are those values, right? You can dig in, you can click into it, you can kind of hover over it, and sometimes it'll give you the parameter. So you can use the named parameters to help disambiguate at the call site what these parameters mean. If you have, in this case, if you have a whole bunch of ints, or if there's a Boolean, how many of you looked at a method that just passes false? Like what's the false mean? There's no context at the call site. Then you have to go look up what that function declaration is and find it. You can use named parameters to help remove some of that ambiguity when you call it. And it makes your code a little bit more readable at the cost of a little bit more code to write. But where this really comes in handy is my next favorite feature, default parameters. You can do this, right? So in our function test, we have a parameter called foo. It's an int, and has a default parameter of 42, which means then I can do this. So now I don't have to pass in foo when I call it. And the compiler knows that the 13 I'm passing in is meant for bar. But I don't pass in a foo, so the compiler will actually inject this default value for me, right? And where this gets more useful, and I use this a lot, is now I can do this and not pass in any parameters whatsoever. And it just works because these parameters are both defaulted. And this is really, really nice if you have like a long list of parameters, which is not my favorite. But this really helps to reduce when you call these methods. And most of the time you're using the exact same value, but you're having to say like maybe overload it so you can pass in. How many of you have done that? That's usually the pattern, right? You have like one big method that takes in a bunch of parameters, but you only usually want to call it with like a smaller subset, so you like overload it and take that subset and then chain or delegate the call with the little defaulted parameters. Everyone's written code like that, right? Yeah, it's okay. This fixes that problem. There's not a whole lot of overloading going on in my experience with Kotlin because a lot of it is done for these default values, and this cleans up so much code. I'm actually working on a project now that has like 3 or 4 variations of a particular method because sometimes it takes an options object, sometimes it doesn't, and this and that. But it's all in Java, so my interface now has 4 variations of like 3 or 4 different types of methods. So now there's like 12, 16 methods in my Java interface when I could have just done with like 3 or 4 in Kotlin because I could have defaulted the parameters. It's hard to overstate how nice that particular feature is, for me at least. And then, of course, you don't have to call everything. If I just call with just the first one, it'll start matching from the left over. In this case, foo will get 42 and bar will get defaulted to 13, which is nice. All right, that's functions. Default parameters, nullability, smart casts. Okay, well, while we're in functions, let's take a look at smart casts. So in Java, if you're taking in a type, let's call it object, right? You're pretty sure you're looking for a certain set of types, right? But you have to take an object because there's not a parent type. This is actually probably bad coding style, but we've all written code like this, right? Your method takes in an object. You say if O is instance of whatever, then inside your if block you have to cast O to whatever, assign it to a variable, and then you can use that variable to call all the methods on that type, right? Everyone familiar with that pattern? It's terrible. It's verbose, right? But we write it all the time because that's what Java makes us do. So Kotlin has what's called smart casting. So it knows past a certain point, certain assumptions can be held to be true for a certain type. So in this case, let's say it's bar. If we just wanted to say, I don't know, let's say x is equal to bar times 2. Now this is, you can see here the asterisk has has a red squiggle under it because bar might be null, right? And if you try to multiply, that's going to give a null pointer. So one way to do that is you could say if bar not equal to null, I can't type today. It's the pressure of being on stage, I suppose. There. Now we've checked if bar is not equal to null, and then we just do the calculation, and you can see the red squiggle went away, even though we're still using bar, right? Bar might still be null coming in, right? But because of the smart cast, inside the block of this if, we're only going to get inside this if when bar is not null, right? So inside this block, bar has been smart cast from int question mark to int, and then we can just use it as normal, right? So that's one form of smart casting. And if bar was any, so now we have a red squiggle for a different reason, but we're going to do this. If bar, hopefully this will work. Okay, so in Java we have instance of, which we've all been around Java long enough. We know what instance of, you know, but I talk to a lot of like beginning Java people, and they're like, what is that? What does that mean? But this reads like English, right? So if bar is an int, you know, like anyone, a non-programmer could sit down. They may not know what int is, but they know what the intent of this is, right? If bar is int. So this is the equivalent of type checking in Kotlin. In this case, it's also smart casting. So it knows inside that bar is an int, and it knows that it's not nullable. So you can do your math on it. I want to say you can do this. So now we know that bar is at least a nullable int, and then we still get the red squiggly, because bar might still be null. We know it's an int, but it still might be null. So you're kind of smart casting half the problem way, or you can do it the whole way. So this is one way to deal with type checking and nullability. So, but to go back to the original null, let's make this back into an int. So this is one way to do it. This is the Java way to do it. It's fine. It's comfortable. There's a nicer way to do some of this. And in this particular case, you could either use this if like we're doing now, or this next bit, which I'll cover. It's probably overkill in this particular case, but I'm going to show it because it's simple. You can do this. You have your variable bar, and you have your dot operator. There's an extension function, which we'll cover later, called let, right? So you could do this. So what this says is if bar is not null, we're going to call the let function, which is an extension function which takes bar as its sole parameter. Now you'll see internally it's all gray, so it might be hard to read in the back. The type hint on the front on this is a lambda here. There's a parameter called it. That's the default name of a parameter for a lambda that takes one parameter anyways. And it's of type int, not int question mark. So in this case, we know that it is going to be an int, and then we can reference that inside our closure, or inside our lambda, and just say int times 2. So if you had a more complex structure, this is obviously a bit more useful. It's also super useful if at the end of if you have like a collection of strings or whatever, and you're doing, map this and filter that or whatever, at the end of it, you could do this whole expression and then save yourself having to save things off into a local variable because you get one for free. You could name it explicitly if you wanted to for whatever reason. If I could type. So now we're explicitly giving it a parameter called not null, and you can see it has vanished because we're only given that if we don't declare something. So if you're doing a lot of like nested lambdas, which happens, at some point you're going to have like 3 or 4 it references, and it suddenly becomes very unclear which it you're talking about potentially. It's always the inner scope, but when you're reading code, it gets confusing. So you can explicitly name the parameters if you want coming into a lambda, depending on how complex your code is. So this is usually the nicer way. It's certainly less verbose than saying if bar not equal null. This is a little bit more idiomatic. It's less to read. Right. So you can also do, the interesting thing about it is you can also assign something. Let's say we want to return x. It's going to complain, but that's fine. So in this lambda, the very last line is x. We don't really need the local variable. Let's just do this. We want to double the value if it's an x, if it's not null, right? So we can still see that value is an int question mark, because if bar is null, we're not going to get a value out, right? So we're going to get null back, which maybe is fine and maybe not. But you can also do this with let. So you do the Elvis operator. So if let never executes because bar is null, we can now provide a default value, and we can get back int. So we're either going to get the double of bar if it's not null, or we'll get 0. And you get a nice kind of succinct syntax for doing that. And you can do this exact same thing with an if and an else, but it's just a lot more code, a lot more ceremony for essentially what you want is you want a default value in case you get a null in this particular case. So this is a lot nicer. And we'll cover this more when we start talking about some of the control flow semantics in Kotlin that differ slightly. But almost everything in Kotlin is an expression. You can return values from almost everything. So if, try, how many times have we declared a variable, then do like a try catch, and then hope that the variable afterward is not null because we didn't catch it, we caught an exception or whatever. With Kotlin, you can actually just return a value out of your try, which is handy. But we'll look at that in a bit. So this is the idiomatic way of doing an if else. Foo.let, blah, blah, blah. Okay, so enough of that. All right, so we've talked classes. I'm going to delete these just because it's a lot of noise down here. Now we've talked classes, we've talked functions, we've talked properties. One thing we haven't talked about is static. Kotlin doesn't have static. I know it's the mainstay of Java programming. You have a constant. It's a static field somewhere. But Kotlin doesn't support static. What it does support is another type called an object. So an object looks like this. And we already have an author type. I'll just use foo. It's a meaningless type. So we have an object foo. Now what this gets us is who's written a singleton in Java? You have your static final holder with an init block and you initialize it. It works mostly, but you have to do it yourself and you have to get it right, and we all screwed up. So what object gets us is if you've ever used Scala, you get a type called foo, but you only get one of them. You cannot instantiate foo, but you get one instance of it for free, and it's guaranteed to be the only instance because the compiler takes care of it all for you. So in that, let's just call this singleton, just because we have a foo function. So now in our function foo, now, okay, we'll use it here in a second, but so an object, all the rules that we looked at for classes apply to object. Because it is a class, we're just telling the compiler there's only going to be one instance. But everything else applies as if it were a class. So you can have var name is equal to Bob. You have here fields. You can extend things. You can implement interfaces, which we haven't seen, but we will in a moment. They work just like classes. But then to use them, you would do this, singleton.bob. Oh, singleton.name, not Bob. So it looks like you're accessing static fields on a class, right? But you're actually accessing the single named instance of this object, and it's the same as the class name, right? Right. So in general, if you want like a static value somewhere, you'd put it on an object. Now, normally you'd want static values scoped to something. It's internal. It's the name of your queue on Kafka. But you want it to be a constant somewhere because it's everywhere in your code. Maybe it'll change. So you declare the constants, right? It's what we do. And you have all your constants at the top, and then you just use them at the bottom. And then if you change them, you just change your constant. Everything's fine. So you'd want those scoped to whatever class you're in, right? In Kotlin, it would do this. Every class in Kotlin has what's called a companion object. And you get one for free, but there's nothing on it, so it's not terribly useful. So if you wanted to declare one, you can say companion an object. So it's an unnamed object in this case, because the name is implicitly taken from the enclosing type. So in this case, we have a companion object called book that's scoped to the class book, and then we can do this. Let's get rid of singleton. We have no more singleton type. You can reference them directly internally to book because it lives on book. But the proper way, of course, is to do this. So now we reference book.name, and now that's starting to look a lot more like a static field on a Java type, right? But you're actually referencing, you're dereferencing via the companion object. And if you have multiple classes, it starts to look a little bit more sane. In this case, IntelliJ is telling us it's redundant because you're internal to this, but if we were in a different class and we had a function here, we could say book.name. And you'd have to dereference this way because I don't think, that's not going to resolve properly. And it's going to import it. So externally to the class, you'd have to reference it via the companion object name. And so this companion object is put where typically you'd put like all your utility functions, your constants, things like that. And it's a nice way to kind of namespace them off away. And like I said, these objects, they're just like classes. So you could mark it as private, and you see this book.name resolves properly. This one gets us a red squiggle because it's private. So you can scope them just like you would anything else. While we're on the notion of private, Kotlin has the same basic, almost the same set of access modifiers as Java. There's public, there's private. There is not a protected. Oh, there is. There's one that's different. Package, there's no package private. That's what it is, because in Java, package private is no modifier, right? But in Kotlin, no modifier is public, right? So there's no package private in Kotlin, but Kotlin does have something similar called internal. Now, internal, basically you're scoping it to that particular. It's called a module in Kotlin, which is confusing because now there's Jigsaw. So if you're in pure Kotlin, this is useful because it scopes it to certain compile scope visibilities. I don't know that it plays well with external Java things because the access modifier stuff inside the bytecode, I'm not sure supports quite what this notion does. But the compiler can make use of it in terms of Kotlin code. So internal's not used a whole lot, at least in my experience. But those are your public, private, protected, internal inside Kotlin. Normally, you'd use public and private is what most people use. So, okay. Interfaces. Any questions before? Yes?
You didn't explicitly mention it.
Yes, and we'll actually look at that explicitly. There's a section later on where we'll talk about, Kotlin's awesome, but I need to use it from Java, and there's a couple of weird wrinkles that come out and how to fix those. All right. I'm trying to pace myself properly. Am I going too fast? Am I going too slow? Just right. Uh-huh. Right. The question is it smart to use the smart casts? Yeah. It's a qualified yes. There are certain cases where smart casting won't work. It worked for us in this case because it was a parameter on a field, on a function, right? So in that case, it's very well scoped, and we know that in this case it was like bar. For the execution of this particular function, this particular execution, we know that bar is going to be one thing, right? So we can smart cast it and it's fine. But if you're dealing with properties on a class, smart casting won't necessarily work because in any application you're potentially dealing with threads. So in between the time you do the null check and then you try to use it, some other thread may come in and reset that value. So the if check goes through, it's not null, we're in our block, and then someone else comes in and sets it to null before you use it, and now suddenly you have a null pointer exception. So that's where like the if not null breaks down, and that's why the let approach is preferred. Because what happens is we said bar question dot let, and then internally we had that it reference. So what happens in that case is the value that gets passed in to let, that populates the it, is a non-null value. And then that scoped that particular execution, and we know that it will never be null because we've passed in that value at that point. So someone else could come in and change bar if it was a property, but it will always be not null because it's what got passed in at that particular moment in execution time. So for the duration of that lambda, it will be not null, and bar could change a million times and it won't matter. Does that make sense? You think so? Okay. We can circle back if it doesn't. Did everyone follow that? That's why, for me, let is better in general, even on function parameters, because it's one way of doing things. You don't have to think about it. You don't have to kind of worry about the context of it. It just works, and it's less code, typically speaking. So, okay, so interfaces. Interfaces look pretty much like what they do in Java. I have getting back to the library model, which we're not making a whole lot of use of, but that's fine. In this case, there was a loanable, because in the library example, you go to the library, you have books. Of course, there are books in libraries, but there's also magazines you can rent, or you can check out DVDs, you can check out all sorts of stuff at a library. Anyways, so loanable represents that, and they look just like everything else. Very familiar in Java. You can extend things. Let's just pick one that I know is a terrible option, but you can extend other interfaces like you would. It's always a colon. There is no extends interface distinction like there is in Java. So in this case, you don't have to worry about am I extending an interface or a class. Of course, with interface, you can only extend other interfaces, but in a class, sometimes you have to worry about, and you have to move it, like, oh, it was in the extends class, I have to move it to implements, and it's a pain, it's a hassle. Kotlin doesn't care in that sense, at least on classes, but interfaces can, of course, only extend other interfaces. But you can declare methods. I don't know. Let's say you have a checkout function because you want to check out this book from the library, and it takes a date. I don't know, whatever. Wait, this is Java 8, right? Oh, I don't have that set up. Is it date time? Local date time. So I can take parameters. You'll notice there's actually a function body on it. So what is expecting a top level? Oh, there. We have an interface. It looks roughly like you would expect a Java interface to look like. Now Now, this used to be a lot fancier back before Java 8 hit. Yes? Do interfaces have companion objects? Yes, they do. I was going to answer with a confident yes, but then I realized I never actually tried it. But yes, they can have companion objects. Primarily because Kotlin interfaces are or were more powerful than Java interfaces. So what I was going to say is this used to be a lot nicer back when Kotlin first came around because you could do default methods on an interface, but you couldn't in Java, right? And it was especially important for Android people because this compiles down to Java 6 bytecode, so you can do all this fancy stuff in your source code, still compile down to Java 6 and then deploy to Android, right? Whereas if you're trying to use Java 8 on Android or whatever, Java 11, there were steps you had to go through to get it to work on Android. But Kotlin just compiled down because the compiler is intense. It's less of a selling point now because we have Java 8 with default methods and stuff, but it's okay. But the same rules sort of apply in Kotlin as they do in Java. You can have functionality on an interface, but not state. So, sort of. You can do this. You can actually do this in Kotlin, which I don't think you can do in Java yet. It's been a while since I've played with it. You can actually declare a property on your interface in Kotlin, right? And then you can do this dot date is equal to date. Let's rename this so it's a little less ambiguous. So you can actually do this. You can write whole methods that access properties and everything. And it looks weird because we're not used to having state on an interface. But you don't technically have state yet. What this means is that whenever someone implements, let's just do this. We're going to check out a DVD because I'm old, right? Who uses DVDs anymore? So we're going to have a class called the DVD, right? And it's a loanable. And of course we get the red squigglies because we need to implement the interface and we haven't, right? So we're going to do this manually. Let's override checkout. So now we have a function called checkout because it's on an interface, and you'll notice this. There's an override keyword. Did I see a hand coming out, or are you just like raise the roof? Sorry, it's too low is what she's trying to say. So we have our function and we've overridden it. Now in Java, we've all used the @override annotation, right? It's nice, it's useful, but it's an optional thing. Who cares if it's there or not, right? It's just really for us. If you use it and you break the overriding, the compiler will complain. But if you don't use it and you change the signature and it's no longer overriding the method, the compiler was like, okay, I'm going to compile it. Kotlin actually requires the override keyword. And if checkout gets removed from the interface and I'm still using the override, it'll actually fail to compile. And if I don't use the override keyword, I'll get the red squiggles because it says checkout hides member of supertype. So we have to explicitly add the override modifier. And that's true of functions, whether it's on an interface or a parent class. And it's also true, as we'll see. Now you'll notice we still got the red squiggle on the class DVD because we're not quite done with the contract or the interface yet, right? It wants to implement, remember that date property we defined? It's not actually, doesn't exist on that interface. You have to implement that because we've declared it as a contract. So now we've got a property on our class loanable, on our class DVD, because the loanable interface says there's going to be a property available for people to use. And in this case, IntelliJ generated, I don't know why it does this necessarily. It generates gets and sets for us, which we don't really need, so we can do that. But we need to give it a value, right? But we could do, let's see if it'll let me do this. We can, I don't know if you can read the menu. It says move to constructor parameter. Duplicating property. Yeah, it's not going to like it. Oh, No, it did. We can do this instead. So we can declare it as a constructor parameter because the interface says it's not null, right? And we don't want to use Lateinit because it's dirty. But we just declare it as a constructor parameter, tell her that we're overriding the property defined on the interface, and we're done. Now in this case, it was complaining because all we're doing is calling super, and we don't actually need that implementation, right? Because we have a default implementation up here, which assigns the function parameter to the property. So now our class gets really simple, and this is useful. For this particular case, I'm working on a library where I'm trying to deprecate a whole bunch of methods and kind of funnel people into using like one set of methods because I want the implementation class to be very slim, right? Because as I mentioned, there's like 18 different overloads that I don't really need because Java doesn't support the default parameters. So what I'm actually doing in that case is I'm using these default parameters default methods on the interface to then do that heavy lifting. So you can do something like that here where you can do like all your kind of grunt work on the interface, and then your implementation can be much slimmer because you don't have to deal with some of the other logic up front. And it can make your actual implementing class very, very simple. So that is interfaces. Implementers must provide that. Right. Okay, so we've gone over functions and Varargs. Okay. Part 2. We haven't gone over Varargs. Does everyone know what Varargs are? It's where the function parameter with the ... on the type. So let's take a look at some of that. I'm going to create a new file, if it'll let me. Where are we? I'll go into model, new Kotlin class, functions. I don't think I have. I have a whole bunch of classes that already show some of this. All right, let's look in functions. Move it over. No, it's not going to do it. It wants to put it in the wrong tab. Functions. All right. Fancy. There it is. All right, so Varargs. In Java, if you wanted to write Varargs, you'd have the ... annotation, right? So you'd have type ... in the variable. Kotlin uses the Vararg keyword instead, which is handy, I suppose. I suppose it's a style thing, it doesn't really matter. But you treat it the exact same way. It looks like an array internally, so you can do a for loop and print it out. So there's a little bit to unpack here. Right. So let's do this. So we're going to call our function is called Vararg, right? It takes a Vararg of strings, and we're going to call it, and it looks like just like you would in Java. It's a variable extension, and we're going to do this slowly here because there's a little bit to unpack. And you can call it with however many parameters you want, 0 parameters, 1,000 parameters, and it just works. And we're going to print it. This is I like doing it this way because they're unit tests, and I can run each little bit, and you can watch it happen. So here's our Vararg, right? Now, this bottom bit, I've literally never figured out quite how to get this to expand up so you can read it, but it's just the debug view. And down below, there is, hopefully that's reasonably readable. You see we get the array of string, right, like we would expect. And then we can step through it with our for loop. Now, this for loop, it should be reasonably, it should be readable. It's not complicated. It's just like the for each iterator in Java, essentially. So I don't want to dwell on that. But I do want to look down here. You can see we're doing print $string. One of the nicer features of Kotlin, again, is it has string interpolation. So in Java, we could just do that, and we can just print it. But what we're doing here is we're trying to print everything out on one line. So we need this space afterwards. So what we're doing here now is this is actually a variable reference. So we're dereferencing the string parameter in the for loop. And you can reference variables directly inside your string. So that happen to do like string.format or string concatenation. If you've ever used string interpolation in another language, this will be very familiar to you. It's super nice. In this case, it's a simple dereferencing of a variable, but you can actually do complex expressions in there. So again, if we just wanted to print out lengths because we just love dealing with how long strings are, you can actually do that too. You just wrap it in braces, and you can do complex expressions in there. You can actually do if statements in there as well, because whatever's in the brackets basically gets evaluated and returned. It starts getting more complicated when you start doing too complex expressions in your strings, because now the whole point of string interpolation is to make it readable, so you know kind of what you're printing. And the more complicated these expressions get, the harder it is to figure out what it is you're actually printing. So I wouldn't recommend doing that in there, but you can if you wanted. Thought that was a hand coming up, but it was just a head scratch. It's like an auction. $1 million. Anyways. So that's string interpolation, just an aside while we're here. And then it prints out on the command line on the console. There, I'm a number of arguments, just like you'd expect. Nothing terribly fancy going on there. Now, if you've dealt with Varargs in Java, it gets a little bit complicated when you have a list. You have a list of strings and you want to pass it into a Varargs argument. It gets a little wonky because you have a list, but it expects an array, essentially. So you have to do a little bit of work to make it, to convert from that list to an array. So Kotlin offers what's called the splat operator, and it is this guy. Right? And that basically says, take this, whatever this thing is, and then splat it out, like you're throwing on the floor, I guess. So you can take your array, you can take your list and pass it to a Varargs with this splat operator, and the compiler will take care of converting it to the right call signature. So in this case, we're doing it one of two ways. In this case, we're passing an array of strings to Vararg, and we also have this list that we're passing. So to convert to the list, I don't think it works with just. Yeah. So the splat doesn't work with the list, so we still need the array, but we have this. So you have your list in Java, right? And you're trying to convert it to an array. You have the like list.toArray, and then you have to like new string 0 because you have to give it the type, otherwise you get back a list of object, right? Surely everyone's done that, right? That's annoying. It's just a lot of code. Kotlin provides this two-typed array that'll do it for you. You can, let's do this. So we get our type hint. We can see it's an array string. There is a toArray, I believe. Don't make a liar out of me. Oh, it did make a liar out of me. There it is. Oh, because yeah. There is a toArray, but it takes a closure, or it takes a lambda to do things to it, which we don't want. What we do want is we want the typed array. This is almost always what we want when we're going from a list to an array. We want the type. So Kotlin has this function, two-typed array, that gets us back an array string. And then when we have that, we can call the splat array or the splat operator, and it expands it like you'd expect. So that's handy. So that's Varargs. I don't know how often you'll use Varargs, but it's interesting to see that they're there. What else do we have over here? Spread operator. Okay, so it says 92 minutes left. Okay, I'm going to cover extension functions, and then I think we'll be at the break, and then we'll go. Yes. Okay. I have 92 minutes, so according to the clock, I have 2 minutes left on this section. Is that fine? Okay. Sure. Would you use the what? Yeah, on each the question is if you had a Vararg of any, would you still use the is operator in the case of Kotlin to check the type? And you'd have to do that at that point depending on what you're doing. If it was just logging, it wouldn't really matter because you're just passing in the type and it's going to call toString on it, whatever it is. But an instance of what? Yeah. Yeah, I'm glad you asked the question. I realized something else. I think I remember this correctly. I think you can actually do... Is it going to let me do that? It does let me do that. One of the constraints of Varargs in Java is it has to be the last position in the parameter list, right? With Kotlin, not so much. You can actually do Vararg of this. And now this might make a liar out of me, but let's see how it works. Yeah. You can't do multiple Varargs, which I was reasonably sure was not going to be the case, but I thought, let's try it, because why not? But you don't have to have Varargs in the last position of your parameter list. And that might help you out with certain like semantics, because sometimes it makes more sense to list things before others. I don't know how much you'll run into that, because I don't typically use Varargs a whole lot necessarily. But it is an interesting distinction. Okay, so let's talk extension functions. Now, I gave a talk at the Java users group in Atlanta on Kotlin, and I lost a few people here a little bit, but I'm going to try not to lose people here. It's not complicated, but there's a few terms that might be new. So in this case, we have a function, a test called titles. And one thing you might notice here is I actually have a local function inside my function. You can do that in Kotlin, but you can't have local functions in Java, which is, most of the time it's not a problem, but every once in a while it'd be really nice to have, like in this particular case, I'd like to offload this to a function. But then you have to like write a top-level function, make it private because no one else should call it, and it's weird. But in this case, you can actually scope a function to a function. And you could scope a function to a function that's scoped to a function, and it's turtles all the way down, sort of a thing. So you can have local functions, you can have local classes if you want inside functions. Super handy for encapsulation. So I'm slightly over. Okay, I'll go real quick. So let's look at title casing a string. You ever taken a string and what you want to do is for every word in the sentence you want to capitalize the first letter in it. So it's someone types in war and peace, but you want capital W and then capital P. It'll be capital A too because our implementation is naive. But you want it to be title case where the first letter is capitalized in every word in the sentence, right? So normally you would write a static function somewhere on a utility class and you'd pass in your string, and it's fine, but there's a lot of ceremony involved in calling it. So Kotlin lets you write what's called an extension function. So if we were to look at a normal implementation of it, in this case we have title case and we're taking in a string, we're going to split it, and then for each element, this is, you use Java 8 streams, everybody? Okay, good. This shouldn't look terribly exotic then. So we're going to split it, and we're going to go through, and we're going to map each element of the string. We're going to uppercase the first letter, or first character, and then we're going to take the rest of it. And then we're going to take it back, and we're going to join it back. Oh, there's a bug. There, bug fixed. I was dropping all my spaces. So one thing to notice here is that we're dereferencing the character in the string with the bracket, and we'll come to that later. There is actually an operator overload for the bracket for anything that takes get and an indexed position. You can just use brackets. So if you have a list and you want the fourth element, you just say list bracket 3, right? Instead of like dot get 3, blah, blah, blah. It's very nice. And we'll get to that. So this is how we'd write it in Java-ish, right? Function takes in the string. So Kotlin provides an extension function. Oh, I had the bug in both places. And you'll see it looks essentially the same, but there's no parameter to this implementation of it because this is the extension function. So our function is called toTitleCase, and this is what's called a receiver type. So in this case, we're we're declaring a toTitle case with a receiver type of string. So anywhere where there's a string in this particular compile scope, we can just call toTitle case. Does that make sense? The receiver type is interesting to note for stuff we'll look at later, I hope. But that's the official term for it. It's the receiver type for this particular function. So then what that lets us do is, if we were calling our traditional title case function, we can run this, we'd pass in a string, I'm but a simple string, and it'll print out. Or we could do it this way. We can take a string, we have a string constant, and then we're just calling toTitle case directly on that string reference, right? So it looks like from the Kotlin library or the JDK or whatever, there's a function called toTitle case on string, but there isn't. We've just extended it with our own particular function. So you can call it directly on a reference if you wanted to, whatever that type is. Or if we wanted to save it off to a field, we can call print s.toTitle case. And this will work because s, if we get rid of this, oh right, I won't show the type in because it's a string. It knows that s is a string, it'll call a title case. But to make it a little bit more confusing, if s is an any, this no longer works because these extension functions, just like static method calls, are bound at compile time. And at compile time, the type of s is an any. Even though at runtime we know the type is going to be string because we're clearly assigning it to a string, this call to the extension function is bound at compile time, and this will fail now because s is an any and not a string, and there is no toTitle case on any. Does that make sense? Okay. So that's extension functions, and I think there are other things we'll cover when we get back. But I'm now 5 minutes into your break, so we'll be back here in 25, 30 minutes. Have some coffee, use the restroom, do some yoga, whatever you need. Thanks for coming back. I know it's a long morning, and there's a lot to take in. Before we jump back into it, are there any questions before we move on? Yes?
You used the Vararg keyword to name one of your functions. Are there restrictions on keywords?
It's okay. So the question is, are there? Because I used. If I go back to where did it go? Was it? It was in the functions class. I used the word Vararg as a function name, which it didn't even occur to me, to be honest, that I doubled that up because I used a keyword as a function name. And the question is, are there any restrictions? And the short answer is yes, there are restrictions. Kotlin is actually a little bit better about it in that sense of being able to use keywords as names. And there's actually, I don't think I can, let me try this. If I tried to declare a variable called in, okay. So it says expecting property name or receiver type. So I tried to use the keyword in as a variable name. I wonder if I can do. Right. It's interesting that it let me use Vararg as a function name, but not the keyword in, for example. And I certainly can't use fun. So there is a little bit of flexibility in using keywords depending on what the context is. In Java, of course, you can't. You just have to name it something else. Kotlin provides a little bit of an escape hatch where you can do this. If you use backticks around your names, then it basically escapes out of the keyword, whatever. So you could actually have a function named fun if you really wanted to. You just wrap it in backticks. It's a little awkward, but you can also do you can do this. You can actually have spaces in your function name, which is not entirely useful in general, but if you ever do like BDD, any behavioral driven, whatever that's, development. If you do like Spock-based tests or anything like that, a lot of the method names read as sentences, So it'd be, like, given a string, it should be less than 80 characters would be your test name, for example. Ideally, you'd want something like that, so when you read your test failures, you can see what the case was. Anyways, so you can actually wrap it in backticks and name your functions with strings, with spaces in the names. Probably only useful in certain testing scenarios, but it's your code, go nuts, right? Okay, so we did extension functions. I will mention just briefly because it's interesting. I don't know if I do it in here or not. I forget. Oh, I do it. Okay, so it says I do it. Right. So we have extension functions, and we've used them. They made sense to everybody? Extension functions. Okay. It's not terribly exotic. It's a lot of like compiler syntax fun for you. You can also do extension properties. So you can actually add a property to a type, which it still feels weird to me, and I don't really use them, but they're there, and I will show you a very brief example. Maybe it'll make sense to you, and maybe you'll enjoy them. I don't use them so much. So let's say that we have a student. Okay, I didn't cover data classes, but it's here in my script somewhere. We'll get to it. So we have a data class student. It's just a class. And so we have students, and we have a class which has a list of students. Now, we want to find the oldest student in the class. We could do this as a function, of course, but I wanted to show a property. So given a class, who is the oldest student in the class? So we define an extension property. And it's defined just like you would a function, except you can do the property itself has a receiver type of class, right? And then we define the getter in this way. So we're just taking all the students, and we're going to grab the maximum age for the student and return that, whatever that student might happen to be. And then to see it in action, you'd have a classroom with a list of students, 12, 13, and 11 years old, and the olders. The oldest, if you run it, you can see, that's why it was a data class. Otherwise, the test is, or the output is nonsense. And it's fix the right class, of course. Hey, there we go. And now you can see the oldest student is 13 years old. Extension properties are still weird to me. Like I said, I don't use them. But they may make sense in the context of whatever you're doing, and they're simple to define. So they're there if you want them, and if you don't find them terribly useful, like I don't, you can ignore them. But I wanted to mention them because we were on the subject anyways. So extension properties. More importantly, let's talk about operator overloading. Now, it's something that Java has forbidden from day one, because almost every language that does operator overloading screws it up. Again, I keep bashing on Scala. You guys have used Scala? Have you seen the operator overloading that happens in Scala code? It's just like a line of just nothing but symbols, but it's functional. It does things, but you can't tell because it's like asterisk, ampersand, parentheses, slash, plus, whatever. They all mean something because they're function definitions or operator overloaders. So Java has avoided it. Kotlin added it, and I was nervous about it when I first started reading about it this years back. But they've kind of gone a much more practical approach, Kotlin has. And I do have, okay. So what Kotlin decided to do instead was define a very strict subset of instances where you can do operator overloading. Because if you just allowed operators to do anything, whatever you wanted, it makes it very hard to read code. And the whole point of operator overloading is to make it simpler to read and write your code, right? But if you can have esoteric operators that do weird things with strange symbols, then suddenly your code starts to lose meaning without being really familiar with the code base, right? So Kotlin has decided to constrain that to a particular subset. So for example, let's take a look at local time from the Java 8 type system, right? From the JDK. There is no if you try to do this in Java, so essentially we have a local time and we want to increment it, right? If you tried to do ++ on local time in Java, it wouldn't compile because what does that even mean, right? There's no way to do that. So what we've done here is we've defined an extension function again, but in this case we've added a keyword called operator, which indicates that it uses an operator. And we've defined two functions, inc and dec. Now, in the list of operator overloads available, there's inc and dec, there's like add, subtract, I think multiply, divide, get, did I say get, set? There's a handful, and I can pull up the list if you're interested. In this case, inc and dec are tied to the ++ and minus operator. So we've defined two extension operator functions that will increment and decrement the local time, and in this case, we either add an hour or we subtract an hour. And then that lets us say now ++, and if we were to run this test, you can see the time is 11:40, and then we add order of operators. Yeah. We're going to add, it's still not doing it for me. Save it. Message, interesting. See what this plus hours. This is where my test might start failing on me. So we defined, where is it going and why is it not doing it right? Oh, no, I'm an idiot. I'm looking at the wrong number. Sorry. I'm not quite jet lagging, but I'm not quite all there yet either. So you can see now it's 11:41, which is the proper time. Then we're adding an hour, and it's 12:41. I kept looking at the minutes and like, why is it not going up? But I'm tired. So we print the message, we printed now, and now we are decrementing, and we get back to 11:41 as we'd expect. And in this case, you see, we should have 11:41 twice at the bottom because we've decremented, but because it's now minus, it returns the now and then decrements it, so we're only seeing the pre-decremented version. But we can do that, and we should get two 11:41s at the end as we'd expect. Can you see it there, that in the back? Yes? There's a certain number of functions. Basically, the Kotlin language defines a certain set of function names that are bound to certain operators. So in this case, inc is ++ and dec is minus. And there's a number of, find me at the break, because I don't want to spend time, but there's a list on the Kotlin Lang website about what those operators are. But it's like inc and dec and plus, or I think, is it plus or add? Might be plus, minus, subtract, divide. But there's like maybe 10 that you can do. But the ones that are the most useful, they're binary operators. Times, in this case, what we're doing, if you want to do, in this case, we're going to print the list 5 times. I've overridden the times operator to return that list to print 5 times. Or in this case, we're printing it 5 times. But the operator itself returns whatever list you give it, and it repeats it 5 times in this case. There's an invoke operator, which is a little bit obscure, and it can be weird, but it allows you to, the invoke method bound to the operator lets you basically call, it looks like you're calling a function. In this case, we're calling hello. It's weird to see, but it looks like we're calling a function called hello. But what this actually does is these empty parentheses are bound to the invoke operator function. So if we were to click through to the implementation, it takes us to this guy. And this is useful when you start writing like DSLs and type and such in Kotlin. You can expose certain functionality bound to a particular type to make your code a little bit more simple to read. But it does feel weird calling invoke on a string. But you can do it. All right. There's also, I don't have an example of this, I don't think. There's also an infix operator, but there's a great example of it, actually. The next section, I think, is on well, a later section is on collections, and we'll come back to Infix because we'll see it in action.
Just another question. What's the scope of that override? Is it just within a class?
You mean the scope of the operator?
Yes.
In this case, it is scoped to the class. But one thing I did not mention at the beginning, and maybe I should have, I meant to, I just forgot. In Java, everything has to happen in a class, right? That's the first thing you do. You open a file, you say public class, whatever, and you start writing things. With Kotlin, you can actually have top-level functions and top-level properties that are not inside of a class. And they're just, you'd import them like you would a class. You can import this function. So if I were to declare this top-level operator invoke, in this case, I could import it into another class somewhere and use it. But you do have to actively import it, so it doesn't just show up and pollute your namespace. I do think, however, and I haven't tried it, so I haven't confirmed it, like with most things inside of a package, everything is kind of visible inside that same package, so you don't have to explicitly import a class. I believe if you were to define functions and properties as a top-level member, they would just show up to everything. They'd be available to everything inside that package as well. So that's something to consider when you're just throwing functions into a file, that you may end up with operators available where you didn't intend for them to be. But like with everything else, if you want to scope them to a particular class or inside of a particular function even, you can scope those operator overloads into whatever scope that you need. So, okay. All right, we have a lot of fancy stuff to get to. So I don't want to dwell a whole lot on generics because that's a rabbit hole that we can go down and spend a lot of time on because it gets odd. But I did want to point out something. Generics in Kotlin work pretty much like they do in Java. So if you're familiar with Java generics, you'll be pretty comfortable with Kotlin generics. The difference is this. Does everyone know the PECS, the PECS acronym? Producer extends consumer super. How many times have you been writing a Java class and you're like, is it question mark super foo? Is it question mark extends? It's like it's an odd. If you know PECS, it helps a little bit because if you're getting values out of your class, you're a producer, so you extend it, right? But if you're taking values in, you're a consumer, so it's super, right? So that depends. That changes how you define what your generic wildcard boundaries are, right? But it's a little hard to remember. It's a little obscure. Kotlin makes it a little bit simpler in that sense. It has, you can do your base T, class base bracket T, and it deals with T types, right? Whatever T is bound to. But Kotlin has in and out instead of super and extends. And it works just like it sounds. So if you're going to get T types out, so if you don't really care necessarily what the T type is internally, but when you get things out, you just want to deal with your T's, you can say out T and it simplifies things. But there's also an in. So I had a whole example built up, but I don't want to spend too much time on it because there's other things. More useful things to know in terms of getting code done. If you want to dive down the generics rabbit hole, it's definitely interesting. So in this case, I changed I forget what the term for this is, but I changed it to an in type. And you'll notice that this T now has a red squiggle under it because I have an in generic in an out position, right? So I can no longer return a T out of my interface because it's an in parameter. I can, however, if I were so inclined, I can take in a T, and I can do all sorts of fun stuff because the T's are coming in, right? But they're not going out. So if I were to do this, for example, the in is fine, the out is an error because how it's defined. And then if I go back to out, you can see now the in position is a red squiggle, and the out is fine because it's an out type now. Does everyone follow along with that, roughly? But then, of course, you could just do I don't want to say raw T because raw means things in generics. An undecorated T, and you can use it both in and out positions. So this starts to boil down to covariance and contravariance, and as you're taking types in and out and subclasses, will determine whether it's in or out or neither. So I just want to mention those because you'll see them from time to time, and that's what they mean. And you can see down here with the unwrapper, things start to get red squiggles. But like I said, there's a lot we could get kind of caught up in details in that, and we can discuss them if you're really interested. But they're kind of like more interesting, more useful, applicable details to get caught up on in other areas than generics, because this is a whole talk all by itself. Does that make sense? Is everyone fine with that? Because there are more useful. Okay, so done with generics. Whew. Dodged that bullet. I'm just going to get rid of the squiggles so that all of my later tests will actually work. No more. It still says red. Oh, right, because of that. No more red squiggles. Okay, so let's move on. So I just want to go briefly over the flow control. I don't want to spend a whole lot of time on it because it's not terribly exotic, but it does differ just a little bit. So there's a while do. Let me see. I have a. That's not what I want. Showcase. The when examples. Okay, so there is a while loop. There's a do loop. It looks roughly like Java's. But what's more interesting, and what I have to look up a lot because I don't use it a lot, is the when. So Java has the switch statement. Kotlin does not. Kotlin has a when, which seems like an arbitrary. Arbitrary switch, an arbitrary change to make, but it does function slightly differently than a switch, and I use both so infrequently that I'm always having to kind of look up, like, what's the syntax mean? So just to look briefly at it, so let's take this when expression. So in this case, we're saying when x is 0, we're going to print there's nothing but darkness. It might have been late when I did this particular example. And then when it's 42, it's the answer to life, the universe, and everything, right? That reference wasn't lost on everybody, I hope. It's Douglas Adams, nerd and English. So anyways, so this is what it looks like when you run it. You run simple, and it's 42 because it's the answer. And then if you set it to 0 in this case, you're going to get something different. There's nothing but darkness, as expected. And then if you set it to 10, of course, you got neither, so you're going to get no input or no output from that. And that's all pretty. It's close enough to what how the switch works that it shouldn't be terrible. But it also supports ranges, which is a lot more interesting. So in this case, we can say when x is in, and this is actually this is an operator I forgot of. So this is an operator called the range operator, and it's bound to the range to function, okay? And actually this is a great example because it is also not only an operator, but it's also, I don't have the source code. It's not an operator overload, but it's an infix operator. So you can do this, and what it does is it takes those two integers and it passes it to the range2 function, and it creates a range type, which is a class in the Kotlin library, from 0 to 3, and it's inclusive on both sides. So you'd have 0, 1, 2, 3 in your range. And then when we run this, we're passing in 8, and we're trying to guess the number 7, and 8 is so close but not quite right. But you can define, here's 2 different ranges. You can actually specify multiple values on each particular case for your when. You can specify single value, single value. You can also do a little bit slightly more complex if it's not in the range of 0 to 10. So if we tell somebody guess a number between 0 to 10 and they guess 80, you can scold them. I said 0 to 10. It's not complicated. So you can get slightly more complex inside your cases than you can potentially do in a Java switch. You can also use them for else's if you want as well, or like if-else trees. I'm not entirely convinced of the utility of this particular approach, but it's certainly an option. it actually, one benefit of doing this is it can be a lot easier to read than a giant if-else tree. Certainly, as your tree grows more complex, it's easier to read this sort of a thing than a giant if-else tree, because all your cases are clearly marked. As opposed with an if-else, it can get a little wonky sometimes to read what each particular case might happen to be in this pile. And in this case, as you can see, we used an extension function on int to determine if it's even or not. In this case, 8 is says x is funny. I wonder why it would say x is funny. I'm not going to debug the. Oh, that's right. I think I wrote that initially, and then I added the 1 to make it the odd case, and I forgot to remove it. But that wasn't the point. Anyways, thank you. That was easy. This is why pair programming works, right? Anyways, 8 is a funny number, I suppose. But that's the win. And let me see. I mentioned earlier there's you'll notice there is no break on the win like there is in the switch case. I detest the break keyword in general. The only place I allow it in my own code to be written is in switch statement, because in Java switches fall through from case to case, and it's not the case with Kotlin wins. Like each particular branch executes and none of the others do. So if you want to fall through, for example, in this case we define multiple values because they don't fall through. There's no break, there's no return, whatever. So that's the win. You can also, in this case there is nothing to return in this case, but win can return values. If can return a value, try can return a value. Pretty much anything is an expression, which can help in certain cases reduce some of the boilerplate in your code. So, for example, we could choose to do this. If it's odd, we want to multiply by 2. We'll return x by 2. If it's even, let's say we want to return by 2. And if it's neither, which of course is not going to be, we'll just return 0. So in this case, you could say print line x. And if we were to run it, now we should get, why are you doing this to me? Oh, I'm printing the wrong, and I thought I was going to escape some of this. So there now, we're printing out the value that was returned from our win expression. And then if we go back to our broken even test, we should get 0 back out of it. So you can return these values out of it, which can reduce some of the, again, you have to declare a local variable, do all your stuff, and then assign it inside. It can be that type of code is error prone because you have to remember in each branch on your switch, for example, to assign a value, and you might forget to assign a value unless the local variable is final and then the compiler will catch it, whatever. But with the win expression, if we forget to do something, we're not necessarily guaranteed to get a value out, right? The compiler makes sure that we're returning something. In this case, it doesn't know odd or even. Every number is either odd or even, except I learned 1 is not odd, but that's a mathematician thing. But the compiler doesn't know any of that. It just knows that there's a potential that no value gets returned out of this win statement, and you get a compiler error. And so you get a little bit of help from the compiler to make sure that you at least have like a default branch to make sure that you always get a valid value back out of your expression. So that can be helpful. We looked at the for statement. I won't go back through it unless everyone's terribly interested. It works essentially like the for each statement in, was it Java 8 that added the for each? I forget. I worked at a company for a long time that was bound to Java 6 because we built database driver libraries and we didn't want to force everyone to upgrade to 8, so we were stuck on 6, which is part of why I got into Kotlin, because at work I was doing Java 6 stuff and it sucked. And I was looking at Java 8 and like, this looks amazing. But Kotlin let me play with fancy stuff. So anyways, a lot of 8 came and went and I was still stuck on 6. So anyways, that's a little aside. Okay, so exceptions also are relatively straightforward. If you know exceptions in Java, you know exceptions in Kotlin. Except for, where did you go? Oh, because it did it in the wrong. Work with me. So exceptions. We'll get there in the end. Okay. So as I mentioned, try catch also returns expressions as well. So you can, rather than declare local variables, you can just declare one thing. You can do your try and then return a value out of your try catch. So in this case, we're going to try and parse a number, parse a string and get a number back out of it. And we want that number at some point. But we also want to be able to handle in this case, we're passing ABC, which is not, it's not a decimal number, we'll say. It works if you're parsing hex, but whatever. So in this case, we can try to parse it, we can catch the number, format exception, and we can provide a default value of null. But we do all of that inside your try catch, and we get back an actual value, right? So no more local variable, happen to remember to assign, blah, blah, blah. You can even make it val at that point, and you just know after this we're going to have something that we can work with, and we don't have to worry about it. And this is really, really helpful, again, in reducing boilerplate code as you're moving through. So I don't know that there's a whole lot necessarily to say on that, but I did. Okay, so one nice thing about exceptions, everyone remember me mentioning the nothing type, and I was kind of like, it's there, but try not to think about it overly much. This is where it comes into. So let's say that this is, we'll put this in a method, we'll call it parse, because why not? So in this case, we're still getting back our int question mark, because that's how this works. But what happens if, instead of passing back a null, what if we just really wanted to stop, right? We wanted to throw the exception. You could do, and I know there's other ways to do this, but you could do this. Let's do, now I'm going to comment that out. So now if you look at what happened here, you can see the type int went to int, right? So this is because of a couple of things. So we've declared our type as int, but parse int throws an exception. If we were to do this, we're only going to parse it. We're going to return, it's asking, all right, well, so what the nothing type is useful for, and I'm not going to flail around trying to make it work in a demo. The nothing type says this method will never return. So the return type is irrelevant. And where this is especially important is in the case of exceptions and tries. So try could return a nothing, and you don't have to care about the return type in the exception case. So all you have to really worry about is what the return value is in the try block, because the exception will throw whatever. And that helps you kind of eliminate certain where you have to worry about what is the type nullable, is it not, or whatnot. With a nothing function, it never returns. So the return type for that, or the type inference, can exclude that part from its calculation because it doesn't matter. It's never going to return, if that makes sense. So that's the nothing type. Usually it's around exceptions. Try catch null, blah, blah, we did that. Okay. So, all right, we have an hour left. There's a whole section on lists and everything, and I don't want to spend a whole lot of time on it because it is, if you know Java collections, you know Kotlin collections. Because again, the whole point was to make it as seamlessly interoperable and familiar, but there's a few things to note. You've seen a few references already to some of these. One of the big wish lists for Java forever has been map literals and list literals. Yes. Sure.
Exceptions. You didn't mention that. Does it support also check exceptions as well in Java?
You can declare, well, yes and no. There are no checked exceptions in Kotlin, and that's one of the things I should have mentioned. So you don't have to say @throws on your method signatures, it just happens. At the bytecode level, there are no checked exceptions anyways, and Kotlin just makes that explicit in the source code. So there's a section later on Java interop that we'll talk about. If you wanted to expose that to your Java classes, there is an annotation that you can apply to your function called @throws, and then you can list the exceptions there. So it will record it for the Java bytecode that happens to use it, but Kotlin just doesn't care. You just kind of have to know that they're throwing it there or not. Which I've come to like actually quite a bit. Because it makes, especially when you start talking subclassing and there's exceptions might happen. If you've ever had to like subclass something in a library that you don't own, but you want to throw an exception, you're kind of hosed because you can't add an exception to the return type, so you end up having to like catch and then wrap in runtime exception, and that's kind of dirty. But with Kotlin, since there are no checked exceptions, you just throw your exception, and it bubbles up like it would everything else.
Does it mean that internally converts all the checked exceptions to runtime exceptions?
No. The distinction between exception and runtime exception is a Java C thing. Is at the bytecode level, they're just exceptions. They just happen. It doesn't really matter because it's a JVM function, and checked versus unchecked is a language thing in the Java specification. So in the bytecode, it doesn't matter either way. It's just the Java code the Java compiler enforces that distinction. Does that make sense? It takes a little bit getting used to because I've been doing Java for a long time and I got used to seeing those exceptions, but it actually is kind of nice in a lot of ways. You don't have to deal with some of that, especially if you're dealing with highly nested hierarchies. Anything else before we run through collections? Okay. So as I was saying, Java doesn't have these list literals or map literals, and Kotlin doesn't either. Mostly, but they do have some convenience methods that make it a little bit nicer to work with. So if you've ever tried to like declare like a new map of anything, it gets awkward. You have to do things to make it usable. Like if you're trying to initialize a field with certain types with a map, you have to have your constructor or your init block, and it's like map.put, map.put, map.put. So Kotlin provides a number of utilities for you. And at this point, I want to point out that Kotlin makes a distinction that the JDK does not between mutable map and collection types and immutable collection types. The default in Kotlin is immutable types. So if you see something that is a map, like you see in this inferred type here, it says map of int to int. That's an immutable map. You cannot add anything to it, right? And you get that using map of, and then you can see here, this is actually a Vararg list of elements with the to keyword. Now I mentioned the infix operator that we'd get to later, the infix function really. The to is an infix function that takes its two operands and passes it to a method. This actually returns a pair. Who has implemented the pair object in Java? Like every project eventually does it, right? Kotlin actually has its own pair. I don't know why Java doesn't. So we always have to write our own. So this to operator actually returns a pair of int to int in this case. So if you look at the signature for map of, it takes a vararg of pairs, key to value, and then what map of does is it goes through and it creates a map of those two values with key value, right? So it's not quite a map literal, but it's kind of close enough that I don't really care anymore. To be honest, I'm not entirely sure how you'd make. I can see how it'd be simpler, but it doesn't matter. So this is how you declare inline an immutable map. If you want a specific implementation, I think if you look in here, the actual implementation is a linked hash map, so it maintains the order. Normally we don't care entirely about the implementation, it's just a map. Usually it's a hash map because whatever. If you want a particular implementation, you can say hash map of, or you can say sorted map of, and that will actually return you a tree map. But if you just want a mutable map, you don't care what the implementation is, I just want to like put keys and values in, you can say mutable map of. And usually what you'll do is you'll be using a combination of one of these two, usually. It's not often that I care that it's specifically a hash map. necessarily. Usually when I care about the order or the type of the map, it's because I want a linked hash map, and at that point, I think mutable is a linked hash map. So if you don't care about the particular implementation, you can use map of, mutable map of. But if you care, I need a tree map, for example, and there's cases where you want that sort of lookup, you can get a sorted map. And the same deal with set. It's the exact same. You have immutable sets, mutable sets. You can also have a hash set and a tree set if you want. And then I don't know where the list stuff went. But list is essentially the same. I could have sworn it was there. It is. Did I delete it? It doesn't matter. But it looks the same. There's a list of. There's a mutable list of, and you can also do array list of, if you want. I don't think there's a sorted list of because that would be weird. You can directly instantiate these types if you want. Nothing stops you from saying, hash map, storing it to a variable and putting it like you would in Java. You can do that if you want, but these convenience methods are usually how, at least I've written Kotlin to get to these particular types. Yes?
I didn't see an import there. Is that because it's just directly built in?
It is, it is, I guess, a globally scoped, if you will. It's essentially a globally scoped function inside Kotlin. But yeah, the question was he didn't see any imports because these are, it's like java.lang, right? I think they're actually extension functions defined in probably Kotlin.lang. In Java, of course, you don't have to import anything in the Java.lang package because it's just there. It's like a core part of the language. That is also true in Kotlin. You don't have to import Java.lang. You don't have to import Kotlin.lang. There's actually, I think, like 2 or 3 other packages in Kotlin that you don't have to explicitly import, and I think some of them have to do with like I/O.
You could directly interoperate with Java collection as well. If you
Yeah, if you wanted explicitly a Java util array list, you could import that and then use it. List of will get you, or a mutable list of will get you an array list, but if you explicitly wanted to make sure that this is a sorted skip list, for example, you could instantiate whatever you want directly. These are just convenience methods to help reduce some of the code you have to write, but you don't have to use any of them. And in terms of what they look like, this is just a bunch of code just to show you like what the type is versus what the type is declared versus what you're getting. There's not a whole lot going on there. Operators. Now they do more importantly than what the types are because whatever. There are a number of operators that are defined for these collections, which is where the real value is. If you want to add to a list, for example, in this case I have a mutable list of int. I can just say, here I want to add a 5 to the end of the list. I can just say plus equal instead of list.add blah, blah, blah. You can also add a list to your list if you want, and this will append 12, 13, 14 to the end of your list. You can dereference, I guess, specific index positions, and I alluded to this earlier. This is essentially if you can replace. IntelliJ lets you replace the overloaded operator with a function call. So this is .get, right? But because there's an operator, IntelliJ will let you say you can replace this, and then it just shrinks your code. You can also do assignments the exact same way. In this case, we're replacing the third element, or element in position 2, however you prefer to call it. Or you can do replacements, assignments the same way. You can also remove elements. Now, this is interesting because if you've ever made a list of integer in Java, there is a remove function that takes an index value, right? But how many times I've hit it, like I want to remove the value 13 from the list, and I say list.remove 13, but that value to remove is not a value, it's a position, right? And then you get like weird errors. It only happens with like when you're making a list of integers, but it gets us from time to time. So this is there's a this.remove. Let me see if I can pull it up here. There's a specific function for remove, and I'm not going to be able to find it now, where it kind of cleans up that ambiguity. But anyways. But the point is, there's a bunch of operators overloaded. Oh, remove at, there it is. If you want to remove a specific position value, you can remove at 0. And it's clear that this is the index position that you're removing, as opposed to here you're removing a value. So this finds a value in the list. This just goes to that position. That's what I was looking for. And then you can also do that. With map, it's the same way. You can dereference using the bracket. So you can just say map and then put your key in the bracket value, which is really nice. Very succinct. You can also add to a map with just plus equal. Again, the to value gives you the pair, and then the plus equal is plus a sign is what that's bound to. So if you want to define your own, it's plus a sign. You can do plus equal 5 to 5 in this case, and you're adding the key string 5 with the value of the numeric 5. So you can reference it, you can remove as well, coming back out of it. And then sets have the same sort of thing. And I didn't show it. I used to have it. You can also say map to. Now you can mess with your friends. You can also do assignment the exact same way, coming out of it, which I think we can all agree this is a lot better to read than map.put blah blah blah. So some standard operators added to the list, or added to the collections that make it a lot easier to use. And so this is why, like when I heard that Kotlin had overloaded operators, I was getting really nervous. But they've done a pretty nice job of constraining it to only a certain set of functions that can be represented as operators, and they can mostly make sense. For example, like if you could, what does a multiply operator mean for string? For most people, it means repeat the string n times, but it could mean anything if you're allowed to overload it. You can do that. I've done it in an example. But anyways. So there is a list, and I can pull it up later for the people who want to see it, of what you can define as operators. And then this is a lot of streams operators. For me, the Kotlin API for streams is nicer than Java 8 streams in some ways, in part because the type inferences and some of the functions provided are simpler. In this case, what we're doing is we're taking a list and we're grouping it by odd and even. And there's a lot of commented out code, and I will probably break it, but I will. So this is just grouping it by either odd or even, so it's splitting into two groups and then returning a map of odd with a list of the odd numbers and even with a list of even numbers. And then printing it out. But it has functions like .any, .all. You can filter. Now, the one thing you'll notice is with Java 8 streams, the first thing you have to do is you call .stream, and then you call it. And then you can do all your streaming operations on there. And now this is a little bit of a judgment call between how the Java team decided and the Kotlin team decided. The Java streams are lazily evaluated, like nothing happens until you reach a terminal operator. So once you hit collect, things happen, right? So the intermediate steps, there's nothing really happening necessarily in memory. But with Kotlin, at every call, something happens. So at any point, so here what we've done is all the way through the map, we're mapping things out and we're returning a list of things back out of it. But we could stop at the group by step. And you see at group by, we have an actual map. Where if you stopped at that point in Java, I don't even know what the type would be. It'd be like a stream something, a stage something. It'd be some like weird obscure type that you can't do a whole lot with other than call another map or filter or some sort of terminal operator. But with Kotlin, you can actually stop anywhere in the middle that you want and then do things on it. And now that's convenient from a code perspective. I have mild concerns that maybe there might be some performance issues in there, but on the other hand, I think if this is where your performance issues are, you've probably written really great code that this sort of thing matters that much to the overall performance of your application. But that said, it can probably happen at some point. So we'll come back to an example of that later. What I did want to look at is go back over some classes because there's some cases that we haven't handled, and then I'm going to skip to some more interesting things. you saw it earlier. It was a data class, right? Now, what a data class is, it's basically a special case of class where it just holds data. There's not a lot of logic attached to it, and it's useful in a number of cases. But what is most useful is if you've ever, say it's if you're working with a database and it's literally just like an entity type. There's no logic on it. It's a bag of data that you're going to hand off, and it's going to do logic elsewhere. In Java, what you'd have to do is you have to declare all your fields, of course, your getters and your setters. More importantly, you'd have to write a toString, an equals, and a hash code, right? Because you're going to stick it in a list, you're going to stick it in a map, and you want to be able to use it in ways that means things. In Java, you'd have to implement all that by hand. And it's kind of okay, because if you're using an IDE, you just let the IDE generate it, it's fine. But if you mutate that class, if you add a property, remove it, then of course you have to go fix your equals, fix your hash code, fix your toString, right? So a data class hides all that for you. With a data class, you get equals for free, hash code, toString, and more importantly, and lesser well known, you actually get a copy function. So if you needed to get a copy of this data class, you could actually copy, you can see it here. So we're going to create a copy of Joe, but we want to change his password, right? So there's, if you look at the, I was going to click through to the source code, but it's generated. So what happens in your copy method, it's a generated function in the bytecode, but it has a whole bunch of named and defaulted parameters. So in this case, the copy function would just say, if you have this and other, you would say this.foo equal other.foo, and it would just copy each field, but it would default those values to whatever the original data class was. But this lets you create a copy of whatever your data class is and change only just the values you want. In this case, for example, like we're changing his password. So the original Joe remains the same, but we get a new instance with a new password. Yes?
Is that a deep copy? Is that a separate instance, or is it just a
The question is it a deep copy? And it is not a deep copy that I'm aware of. That's an interesting question, because if it knows that the other fields are data classes, would it do I have a feeling it's not, though. It feels like an awful lot of smarts to build into a compiler. So I would assume that it's not a deep copy until you write some test to verify, but I'd be surprised. But so you get that. One thing that I'll cover here in a second, you also get, Kotlin supports destructuring on return types, which we'll get into later. With a data class, you get that for free. In order to use destructuring, which we'll cover maybe next because we're on it, you have to write certain functions in order to work with destructuring. With a data class, you get those for free for every element on your class, right? So while we're on it, let me just see. I'm not sure I haven't. Oh, it's right here. I wonder why it didn't come up. So, okay, does everyone know what I mean by destructuring? Probably not. I had to learn it too when I first saw this feature. So you return, say you have a pair class or a tuple, and that tuple maybe has 10 elements, right? So in a normal world, you would return your tuple, and then you'd have to say tuple.first, tuple.second, right? You have to manually pull all those values out into local variables, right? It's not hard, it's just a hassle, and it's a lot of code. But with restructuring, you can actually do something like this. So let's, before getting into all that, let's model an HTTP response, right? So normally when you make a call off to some sort of REST service, there's two things you care about, right? The response code and the body. So in this case, that's all we care about. So we're going to declare a data class of HTTP response with the response code that we got back and whatever the body of that response was. JSON, payload, whatever. So we have a function called call. It takes in a URL, which we don't care about because we're not actually hitting a REST service or anything. But what comes back out of this function is an HTTP response. We're going to get a 200 code because we're just playing, right? So we don't really care what's on the other end. So what does this look like then? So you can say response, and you can get back your HTTP response, as you can see here. And that's fine. If that's what you want, you can manipulate it. It's an object reference. You can do whatever you want. But if all you're going to do is extract those values out of the response object, and you don't really need the response object itself, you can actually destructure that call into multiple variables. And so what that looks like is this. You're declaring val because it can be var, I think, if you want. Sure. It's val because we're not going to change it. And then in parentheses, we're declaring two local variables, result and body. And then as you can see, we're assigning response back. So in this case, what we're doing is we're destructuring the response object into local variables. And if there were more than two types coming out of it, you could do, as many as you needed, depending on what it is, right? So, but because response is a data class, we get this for free because the compiler will generate that bits for us. If it was not a data class, we'd have a number of problems, but it would look like this. We would call it, if I remember the name, get component 1 is equal to code. Is that going to work for me? Yes. Now, I imagine at this point you're going to have a couple of questions for me, and I will try to anticipate those. So, must have, it's not get, it's just there. Operator, fine. See, it's a hassle. Even when I sort of know what I'm doing, I still messed it up. Okay, so there are operators, these functions, which I forgot. But there's component 1, there's component 2, you can do component 3, 4, 5, 6, 7, however many you wanted. You could implement this by hand if you needed to, and in some cases you will. But with a data class, you get them for free, and that lets us then destructure those calls back out into local variables. Is everyone following that so far? And this is super nice. If you've ever had a case where you wanted to return multiple values out of a Java class, but you can't, and so then you return I'll just return an array, and that's gross because then you still have to cast things potentially. It's doable. But this is really, really nice. And you don't even have to do, you don't even have to declare a type if you don't want to. You could, if you had this, you could do this. Pair of int and string. All right, we don't want that. We want this. You could explicitly return a pair if you want. There is, I think there's a triple. There's a number of tuple types in there. Pair is the one I use the most. But you could even do that, and then you could then just call your function, and it works the exact same way. So you don't have to declare a wrapper type to get these components out if you don't want to. You can just use pair or triple, or I don't think it's called quadruple. I think it goes tuple 4, tuple 5, or whatever. So you could explicitly do that if you want, and then just destructure at the call site and get back out of it. But that's one of the benefits of using a data class, is you get that for free. So as elements come and go off your data class, you can destructure it however you want. And then if you weren't interested in what the return type is, we don't care what the result is. We might get an error. That's fine. We're just going to print out whatever the body is, whether it's an error message or the JSON payload or whatever it might happen to be. We don't care about that position. You just use an underscore. And then if you have a long list, 10 types, whatever, you don't care about the middle 6, you just underscore, 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 underscore. And then the compiler just doesn't care. And as you can see, our result variable went away because it's no longer declared. So that is type destructuring.
Question about the data class?
Sure.
Is there a default on serializability?
There's a default on serializability. I don't know the answer to that directly. I don't know that Kotlin does a whole lot with the JDK serialization. I think generally the answer would be to use something like Jackson to serialize it and do that, because JDK serialization is broken in many well-publicized ways. So I'd be surprised if the Kotlin team embraced that, because it's such a hazard. But that said, I haven't tried it, so it might be. There's nothing about it that wouldn't necessarily be depending on what your fields are, right? So All right, so with data class, you can actually... Oh, right. You can't override. Well, maybe you can. No, you can't override. So you can't define those components if you're a data class, but you can declare other functions if you want on your data class. Yes?
From the constructions, you have to define every single field that maps onto the data class.
Oh, here, no, it's the same way. So if all you care about is the return code, oh no, that's...
So could you just have var result in there?
Can you do what?
Do you have to have a mapping onto each?
Oh, if you're going to destructure, yes, because it will return whatever component 1 through n is what will come back if you're destructuring. So you have to have like these positional underscores if you want to discard those.
And they come back in the same position as their...
Yeah, exactly. So component 1 will always be position 1, component 2 will be position 2, and if you reorder those at any point, then suddenly that changes, and anywhere where you've destructured is potentially broken. So there are also, we have 35 minutes left. There are enum classes, just like you would have in Java, and enum is just a keyword. So you could say enum class color, for example. Everyone's familiar with Java auth.color. So you can have an enum, and they work essentially the same way as Java enums. There's nothing terribly exotic. What's more interesting than this, let me get rid of the red squiggle. Oh, I don't want to include. I may not have an example of this. Why isn't it finding these? Whatever. It's not finding my types. So what's more interesting is Kotlin has a sealed class, which is, they work sort of like enums. With enums, you get a set of instances already, right? And you can't create any new instances of those enums, but you get like a fixed set of known values, right? So with the sealed class, it's kind of the other way around. You get like a fixed set of known types. You can instantiate however many of those you want, but you can't subclass the sealed class, right? So in this case, we have a sealed class called value, and we have three types. We have a data class constant, we have a data class expression, and we have an object that's not a number that is a value. So these are the 3 types that we know in the system that you can deal with. And where this comes into play is when you're doing those like when expressions. If you're trying to do when foo is an instance of a value, for example, if it doesn't have those 3 branches because the class is sealed, the compiler knows that there's a missing case, right? But because it's sealed, it knows that there has to be a branch for value, for constant, there has to be a branch for expression, and there has to be a branch for nan. Which I'm not sure you can extend an object, but maybe you can. No, can't extend an object. But you have to have those 3 branches in your when statement, because otherwise the compiler knows that there's going to be a fall through that you're not going to catch, right? Now, you might be able to just ignore it with an else and say, yeah, whatever. But the compiler will force you to deal with all 3 branches, right? Which is useful. So the difference here is this. You can extend expression. Like you can create a new type of expression. So you can extend that, but you can't extend value in your own code. And you might ask, what's the point of that? But again, it goes back to these when statements. As long as your when statement has these 3 branches on it, your when statement will handle every single instance of value that it sees. And the compiler knows it can enforce that, right? Because even the subclass of constant is a constant, and the when branch for constant will deal with it. So using this, you can kind of constrain what your possible type values are and deal with those generically in a way that you're confident you can handle all particular cases, and yet still allow, say, user extension of a particular type so they can customize it. If you're building like a library or framework, they can subclass and provide their own implementations, and they can kind of do whatever. So in your when, you can say, if it's a constant, then foo dot whatever function is defined on constant. For example, they can then subclass constant and override foo and do whatever it is they want to do, but you know for sure that in your code, you're going to be able to deal with all possible types of that particular class hierarchy. Does that make sense? I want to do something real quick. I want to talk about, sorry, I want to make sure because we don't run out of time, because there was a question right after the break about Java interop. And that's, for me, that's an important thing, and it's one of the things that killed Scala for me, because I worked in a Java shop. I worked on the Java driver for a database, but I had to do some work with Apache Spark. Has anyone used Apache Spark? It's lovely, it's awesome, but it's written in Scala, which is fine if you're using Scala, but I was trying to use it as a Java developer, and there were things about the API that were just really weird, because Scala C did things for the Scala code that's not available in Java C. Awesome. I love rain. So it made it weird to use the Scala library from Java, right? And so I kind of moved off of it because it was just so painful. I couldn't figure out how to get the magic values into the API that Scala C would do for me, right? And it ruined Scala, at least as a Java developer. So for me, interop with Kotlin and Java is a very, very big deal because my day job is Java. So for the most part, you can use Kotlin code from Java, and it doesn't matter. It's pretty straightforward. Everything sort of works. But there's a few things that are not so great. And I will see if I have... Where did it go? Okay, it doesn't have it. So we're going to start a new one. We'll do it. We'll create one from whole cloth. Where did this? We're going to create a Kotlin class. Interop. Now, for this little bit, we're going to see how well this works. There's a nice feature in this IDE where you can see the bytecode. And this may not be the best way to do this. So I have a Java. Oh, I don't have a Java. Oh, here it is. Let's do this. We're going to create a new Java class. We don't want that. Let's do this instead. I'm going to close this script. And we're going to move. We'll just start with. All right, we're going to create a book. We're going to import it there. I almost typed a val. What am I looking for? Book. I legit just had to stop and think how to write Java there for a second. It happens. So, all right, so this is now a Kotlin type that we're using from Java, right? And for the most part, it looks pretty straightforward, right? I can't even tell that I wrote Java. But if I wanted to call, if you'll recall, let's close everything else and open up book. So let's say I wanted to reference this guy, right? So we're going to say book.name. It doesn't exist. It doesn't know what that is, right? It sort of does, but we can do this. There. Book.companion.getName. And now we're calling it, but it looks weird, right? It's a little awkward. It exposes the implementation details of how that works. So we can do this. We can do this, right? So now we can still do that, but we can also say book dot. Oh, it's still not going to do it. All right. All right, let me check my notes here. Clearly I closed the script too soon. And why won't you? IntelliJ is really letting me down today. It won't let me find. There. Java interop. Where did we go? JVM setting, JVM name. This should work, and I'm not sure why it's not working. Oh, do it on this guy. It didn't like. Not applicable. Maybe because it's a property. Let me try this instead. There we go. Yeah, it was the property. Properties are handled slightly differently, it seems, because they are companions. So we could do either one would possibly work, right? But obviously going through companion is awkward. So you can use @JVM syntax or JVM static to expose that particular function, that particular member as a static member on the type itself, right? So if we were to do, let's add, all right, so our function foo, let's say we're going to rename this. Name is equal to something. And then we'll redefine the ISBN. And we're going to give these default values. Right, I should point that out. Now we can actually reference things directly, statically, instead of having the reference, because that's the whole point. So now if we're going to call foo, we have options. We have string and name, and those are required because Java doesn't support default parameters, right? So now we have to pass in, if all we wanted was to fix the ISBN, we can't say ISBN is equal to some other string. We can't specifically get at that value, right? Because there aren't name parameters. So instead, we'd have to do something dirty like that, right? Oh, it's title, not name. We'd have to do something like that or pass in some sort of value because we have to fill in that first slot, right? And that it's a little awkward. But we can do this, for example, JVM overloads. So now what this does is when it compiles down, what'll happen is it'll generate multiple methods. You'll have one that takes in all the parameters, but then you'll have one method that takes in only the name, and only one method that takes in and then nothing. So on the Java side of the world, we could then at that point just call foo, and because there's an actual proper function there. So you can see now, if you can read it, we now have 3 different methods that we could call on book. One with nothing, one with only the name, and one with both, right? So this helps in the case of when you have multiple name parameters. It's still not great if all we wanted to do was change the ISBN for whatever reason, but it at least cuts down on some of the cases where you have to pass in all the values. So obviously you might want to order them so that those parameters you don't want are towards the end, and then you can more easily just leave those to default and put the important ones up top. But this lets you use then, the defaulted parameters in Kotlin and make your Kotlin code nice to use, but you can still expose methods to your Java coworkers so that they can then get some of the advantage of some of the default parameters. JVM name. Okay, so let's take a look at, remember I mentioned there were top-level functions, so let's create a top-level food that does something. Now, what's going to happen when this compiles down is there's going to be a class called book.kt.class, and we could import it if we wanted to. And so we could call that, right? So when you have top-level members like that, they will end up in a generated class named after the file. So you'll get book.kt, which I think we can all agree is a really awkward name, right? What does book.kt mean? But we don't want that, so we can actually do something like this. JVM name. And we can call it utility. Now the big question is, all right. So before we get into why that red squiggle is there, so at JVM name, if we wanted to show it with something where it's not going to break, lets you change the name for the JVM side of the world. In this case, I applied it to something, and so now something you can see is gone. But we can now call utility because we renamed it for the Java side of the world. So that's useful, but not really what I was wanting to show you in this particular example. But if we went back to here and why it broke, so you can apply annotations to your file if you want, but you probably can't see it. There's a red squiggle there because it doesn't know where to apply that annotation because it's literally out in the middle of your source code. So when you're applying an annotation, Kotlin supports a target. So, for example, if you're annotating this with JSON property, do I have property? Do I have Jackson? I don't. I don't have Jackson in this project yet. So in this case, it's applying it to the property, but you specifically want the annotation on the getter. You could do something like that. And so the annotation in the bytecode shows up on the get. There are some times where it's on, the default actually might be on the get, but you specifically want it on the field itself. You could say at field, and then the annotation gets applied to the field. So I say all that because up here, what you'd want to do is you want to apply the annotation to the file. So as you might expect, you can say at file. And now this annotation, when it gets compiled down, is applied to the file, which is weird because in Kotlin, the file is an active part of the compilation process and not just a container for other types. Like the file is a bit more significant for us. So then what that means down here is now book.kt, you'll notice, no longer exists, right? But we can say utility.toplevel. And so now we can have just a file, if all you have is like utility functions that aren't really bound to anything, but you need some place to put them in a Kotlin file somewhere, and then you can apply an annotation, and then your synthetic class that gets generated, you can name something useful, right? So we've renamed it. Now, I won't go into this example because it's a little arcane and there's some other things to talk about. There are multiple times, say you have functions all over the place that you want to put into this utility class. There's actually an annotation called at JVM multiple file name, and that tells the compiler to collect all these bits, and when you generate the class, it's actually going to pull things from multiple source files, generate one class with all these items in it. So you can actually define multiple functions across your source code and have them show up in one unified class. How useful that is for you is for you to decide. It feels a little dirty to have everything all over the place, but it's an option if you want. Anything else? This at JVM field annotation, so if we go back to our test here, book has a title, but it's just, you see get title, set title, right? But if you want direct access to that field in the Java code, you could come in and do at JVM field for, whatever reason. And now you can see title as a public field inside your Java class. Like I said, how useful that is kind of up to you. JVM name static field, there's multi-file class. Now, one reason you might want to use Java name is Kotlin is a little bit better in terms of overloads. If you have like one method takes a list foo, one takes a list string. Because of type erasure, that won't work. Because ultimately at the bytecode, it's a foo list, and now you have two methods with the same name, right? So if you were to go in and do just that, let's say we have a list of int, and we don't need that. And then we have a list of string. Now, as you can see, the compiler complains because of erasure. You're going to have two methods called something that take a list, right? So you could actually come in and say JVM name something else. And now what happens is in the bytecode, this second function is actually called something else. But you can still refer to it in your Kotlin code as something, and then just either pass it a list of string or a list of int, and you can use it normally. But the bytecode needs just a little bit of help because of type erasure. So you can do fun things like that. Does that make sense? So that's handy, because I'm sure we've all been bitten by that before. And then you have to have weird names in your code, and it just feels dirty. So delegation, destructuring. We have 15 minutes. I want to show you one of my favorite features, and I always get a little bit pushback on it because someone tries to be clever. So Kotlin supports delegation in a number of ways. So earlier we saw that you have Lateinit to get around non-nullable types. But sometimes, say your type is non-nullable, but it's a computed value, right? And you don't want to compute that value every time you instantiate an instance. Maybe you're reading like a backing store of binary data off disk, right? You only really want to use that. You only want to load that binary data when you reference that particular property. And just because you've instantiated type doesn't mean you want to go out to disk or out to the network to pull over all this data that you're never going to use, right? So you can actually mark that field as lazy, which looks like this. So in this case, we have string, and we're going to delegate it. There's a keyword called by, and then there's a built-in delegate called lazy. And so what happens is this lambda is only computed the first time it's called, but it's not computed until it is. So if we run lazy, this is why I comment out squiggles. Try that again. Now, we're going to get there. There we go. So, on the output, you can see, let me see if I can keep this source code in view. So on the output, you see I'm lazily computing this value, and then we get the actual value you want of Inigo Montoya. Yeah? And then the second time we call it, you can see we only get my name is Inigo Montoya because it's already been lazily evaluated once. So in this way, you can kind of defer computed values until the time you actually call it. And then if you, just to drive the point home, we're never going to reference the name property. And now we get no input because we never reference name, so it's never evaluated, right? So you can kind of defer things. There's a number of other built-in delegates. There's an observable delegate, so you can do like property change events. That used to be like a much bigger deal back when the bean spec was something that people cared about, and you're like building GUI widgets and you want like the value change, so you fire off an event to update your UI and everything. I don't know how many people actually use property change events anymore, but you can do an observable kind of whatever. You can also use it for validation. You can reject a change if someone wants to do whatever. So in this case, like if you run it, we'll see. You can see the age is 40. I set the age to 41, and you can see we get the event out of the property change value, and now it's 41 again. So that's one. You can do a delegate by not null, which is a kind of an alternative to Lateinit, and that simply says initialize the value and leave it as a non-nullable type. We're going to delegate by not null, and then you get an exception if you try to reference it before you get a value. So you can see property not null should be initialized before the get. So it's a nicer way to give people null pointer exceptions, I suppose. But it's also a nice way to be able to say the value's coming, just hold on for a second. You'd also get a very similar value if you were just to say this. If it'll let me do it on a, yeah, all right, fine. You can't do Lateinit on a field level, on a file level property. If you were to reference a Lateinit value before you give it a value, you'd actually get like a fairly gnarly looking exception, and it's not pretty. So that's an option. So that's a delegate. Now, but my favorite feature of all of this is you can actually do, you've heard the term favor composition over inheritance. So you can actually delegate, delegate your extension. So in the example that I have, we want to, it's called a listogram. So we're going to extend array list, or we want to implement the list interface, essentially. Has anyone tried to implement like the list interface for whatever reason? There's like 80 methods on it, right? And I don't think I have it in this project. But you have to implement all those methods because they're on the interface, right? And almost always you have like an internal list that you want to delegate to, but then you have to manually write that code to say, add, public void add, and then list.add. You have to write all those delegations manually. And it's a hassle because all you really care about is your specific logic you want to add. So for example, in this case, we're going to build a histogram of the list size over time. So all we really care about is adds and removes, right? But there's other methods on the list we don't care about. In Java, we'd have to have the entire source code. But because with Kotlin, we can do extension by delegation. And that's what this looks like. So our listogram is going to implement this interface, a mutable list, right? So, but we don't want to implement all the methods, so we're going to delegate it using the by keyword again, and now list. So this list is actually a property on the class, right? And then what the compiler will now do is for every method on the interface, if it's not directly implemented in this class, it will generate a method that automatically delegates for you. So in this case, we now have 3 methods on our listogram. We have the add that we care about, so we can kind of mutate the size of our, we can record the history of the size. We have the remove, so we can then update that history. And then we also have what we really wanted to write is the histogram method to print out what the size looked like, right? So instead of having now, all 80 methods that we had to wade through just to see the 3 methods that we care about, we literally just have these 3 methods to look at. And if you look at listogram test, you can see we're going to add, remove, blah, blah, blah. And then once it runs for, I don't know, a few seconds because I have these sleeps in there, then all we really care about at the end is that we get our little histogram. And it's cute, and it's entirely usable and useful. So anyways, so that is delegation by composition, which is nice. If you can use it, it's awesome. But it's one of those nice features that Kotlin adds that Java hasn't for whatever reason, or for a number of reasons, really. That can be super useful if you spend a lot of time extending other interfaces that you don't really care about. It's a little bit of a nice fix for the adapter. If you've ever done swing code, you had the mouse event adapter because you didn't want to implement mouse event. So you had to have like an adapter class that just had like empty implementations, and then you just override the one method you care about. In this case, you don't have to have these weird adapter methods because you can just literally delegate to an actual implementation and only override the stuff that you care about. So, okay. The clock says 7 minutes. My watch says 2, so I'm not sure how that happens. Okay. Okay, well, that covers the bulk of what I wanted to cover anyways. There's always other things to get to that we can happily talk about afterwards if you want. So one of the things I want to mention, but I won't necessarily go into, one of the nice things about Kotlin is there's a new feature from 1.2, I think, called Multiplatform. You probably haven't heard about it. I mentioned platform types earlier, and I said in this case it's the JVM. And that's significant because there's actually multiple platforms that Kotlin supports. You can write Kotlin code and compile it down to JavaScript. So if you're like writing a React app, you can actually write all of your JavaScript parts in Kotlin. Because if you're like me and you hate JavaScript because it's such a weird, broken language, you don't have to write it in JavaScript. You can write it in Kotlin, and you can compile it into JavaScript. And there's also Kotlin native, which lets you write Kotlin code and interact with native code. So instead of writing all of your J and I bits, you just write in Kotlin. You'd compile it with a slightly different compiler to compile down to LLVM bytecode. And so what this lets you do, actually, is if you're an Android developer or a mobile developer, you can actually write your backend in Kotlin, you can write your Android app in Kotlin, and you can actually write your iOS application in Kotlin. So you have one source tree that has your entire application. All your common logic is in common code locations, and then you can just write like platform-specific bits to render the UI, respond to platform events based on what the platform is. But then all of your actual business logic can be unified in one code base, so you don't have like your Android app outpacing iOS or vice versa. But then you can also target JavaScript as well. So that's multi-platform, and that's a friend of mine in New York's company is basically making a run on multi-platform and iOS development using Kotlin native instead of Swift or Objective-C. So that's an option. And yeah, we didn't cover DSLs, but that gets a little esoteric. I can show you some DSLs afterwards if you want. But we have just a few minutes left, and I want to make sure that there are time for any questions, either recent stuff or all the way back to the beginning if I didn't cover something that you were curious about. Yes?
You mentioned that let gives you safety around threads.
Uh-huh.
If I have a data class and I use a let on it, does it allow me to copy all the variables at the same time?
Well, with the data class, the properties are val. I don't remember. Okay, you can use a var on a data class. So with a let, you can be sure that your reference itself was not null, the reference to the data class instance, but it doesn't give you any guarantees on the properties on that particular data class. So in theory, someone could mutate it while you're trying to copy it or print it or save it to database or whatever. It doesn't do anything for you on the properties. So you'd have to safeguard those manually, I think. And I don't know what would, if you tried to copy, you'd probably have the same problem. You could potentially get a copy of the transient state while someone's mutating it. Which is why if you're doing a data class, it's almost always better just to declare everything valid, that it doesn't matter. And if you have to mutate it, then you can use copy to mutate a new instance, and then everyone else gets to use the old copy, and it's fine. So that's what I would do. Any other questions? Did that answer your Java interop questions? Did I cover everything for you? Does that help for you? Hopefully. It'll at least get you started, I hope. There's a few other annotations involved, but they get a little bit more esoteric into some of the details. But usually the JVM static and JVM name are going to get you most of what you need. And JVM overloads. Anything else? Yes?
Is there anything in Java you feel is missing from Kotlin?
The question is there anything in Java that I feel like is missing in Kotlin? I don't think so, to be honest. I mean, nothing comes to mind. I haven't dealt with modules yet, so I can't really comment much on that, but module seems to be not terribly popular anyways. Well, it's not there yet. There's a project called Valhalla, which is introducing value types into the JVM. I was going to show you a feature called inline classes, which I didn't get to. But value types with inline classes and data classes would be an interesting intersect because data classes feel like value types for me because they're literally just like a bag of data. And that's what value types are designed to hold. So I'll be curious to see once Valhalla lands if data classes are kind of realigned on top of some of that. All right, it's officially 1:03, so officially lunch has started. I'm around all week till like Friday morning some point, and I have to fly back to the US. But if you have questions at any time during the week and you see me wandering around, feel free to stop me and ask me questions. I'm happy to talk shop about Kotlin or whatever. But anyways, thank you so much for your time. I know it was fast and it was a long morning, but thank you.